We are back, and today I'm excited because we're going to be talking about TypeScript basics, which is something I haven't done a very good job of talking about yet. So what we're going to do is we're going to start with just learning some of the fundamental concepts and things that we use every day when writing TypeScript, and then I'd like to build some practical implementations of that. And so we'll jump into Horizon, where we can write TypeScript code that'll cause some sort of visual effects, sound effects, maybe some haptic feedback, that sort of thing. We're keeping this super basic, so there won't be any like end product from this tutorial, but ideally the end product is that you've learned the basics of TypeScript and can then go and apply them on your own. So without further ado, let's go ahead and dive in. This is where I like to play. It is the typescriptlang.org/play. Make sure to put a link to that in the description by remembering to have this open on another tab. Okay. And so over here, what we've got is this little playground. And the first thing, if you've never written TypeScript before, is to get something to happen. And you do console.log, parentheses, and then I use single ticks, hello world, exclamation point. Semicolons are optional. I like them. I add it, and then hit run. And over here on the console, you'll see the log hello world. There's a few things to talk about here. So the first part is console. This is a reference to a thing that has all of these values and functions and methods that you can call. And the one that we use most often is log. There is error, I believe, right? Yeah, there it is. So you can log as an error instead of logging it just as a normal log. I personally don't use that one. I tend to just create my own error handling, which I'll explain later. But probably not in this video. But anyway, we've got console.log. And then to call the method log, allowing us to log something to the console, we use parentheses. And then we need to pass in a parameter, which is the data that we're going to log. And in this case, we want it to be a string. And a string is, just some text. And you can do that by using single ticks. You can also do that using double ticks, which is quotes. Or you can use the back ticks or tilde. And there's different use cases for all of them. I tend to use single ticks because it's the quickest to type. It's just one click on your keyboard. Backticks is my fallback when you need to say something like don't, which has a single tick in it. And yeah, same sort of thing would go if you needed something that included quotes, like, yeah. Or I guess if you needed something that included single ticks, right? Or backticks. Let's give it a shot. And we'll hit run. There you go. So you can see that the backticks got included because we were using the quotes. Now the quotes on the outside are always there, so that's not actually relevant. But that should give you a good start there on understanding how this console.log is working. Now, as I mentioned before, semicolons are optional in TypeScript. The reason that you'll see me use them the entire time I code is because I do a lot of coding also in Unity C#, where if you forget a semicolon, the code doesn't run. And so I just like to stay in habit and make sure I'm always writing semicolons. Okie dokie. I think that just about covers the console.log. So we'll leave this hello world at the top. And we're going to start learning about some additional variables like constant and let. And I wanted to make some notes in here. I should have just done these as comments are easy. You just do a slash. You can also comment by hitting Control/, and that'll automatically add the comment for you. And then you do Control/ again to remove the comment. Super useful. We'll do that up here actually, because I like it to look the same. And then we'll come down here, add a comment using that Control/ again, and then we're going to type some of the other things that we want to do, which would be object. We want to talk about a JSON object. Let's call that a JSON object. And then we want to also talk about constant let map. And anyway, we'll get into those in a minute. But the first thing we're going to look at here is these constants and lets. So what you need to know about TypeScript is that it is a superset of JavaScript. And what that means is it's built on top of JavaScript. Now, if you're watching this like 5+ years in the future, they are talking about switching over to, if I'm not mistaken, Go. But for now, TypeScript is built on JavaScript. And so a lot of JavaScript stuff just functions. So if I'm not mistaken, you could technically use var just don't, it's not something that we want to use. We want to use, like constant and let. And what constant is for creating a value that doesn't change. So let's go ahead and write our first constant. So we're going to say the constant, let's see, think of something that doesn't change. Length, feet in a yard. I feel bad for anyone who's not in the US, so we'll say meters in a kilometer. There you go. And that is equal to 1,000. Right? Yeah, there's 1,000 because it's kilo means 1,000, right? I'm from the US, so apologies. Now, what we've done here is we've created a constant variable known as meters in a kilometer. So this is the name of it. And we're setting it to be equal to the number 1,000. Now, this underscore is optional, but what's nice about underscores is it just makes it easier to read. It's just like having a comma, and if you start working on values that are, several zeros in a row, you're going to really want to have those underscores. But again, optional, so your preference. Now that we've created this constant, what you'll see is you can utilize that. So we could write another console log, console.log, parentheses, and we can just pass in meters in a kilometer. And if we just hit run, we'll see that now has hit the console as 1,000, and notice that there is no underscore. Now, what's interesting about this, and just something worth trying here, is if we want to combine this with something. So let's say we have some single ticks here, and we add to it, and then we say meters in a kilometer, colon, space. And so what we've done is we've made a string that says meters in a kilometer. I like to use a colon space when I'm printing a value after it. And then we use this plus symbol to combine two values. And in this case, it's a number. And so the console log will automatically make that number into a string. But in many cases, you actually need to use a .toString to convert the value into a string. And in this case, we don't. We'll run it both ways. So I'm going to hit run, and we can see meters in a kilometer is 1,000. And if I remove the .toString, that should also work. And run. Perfect. Awesome. So now that we got that set up, the next thing we're going to look at is a let. And so we'll go ahead and hit Control/. Now, a let is some variable that can be changed. It's no longer constant. It's now something that's going to be moving. And in that case, we might talk about something like an age. My age is 30, and in a couple months, I'm going to turn 31. Yikes. How did I get to be this age? I know that it's still technically young, but I'm starting to feel old. My back hurts. I see a chiropractor regularly. What's going on? But anyway, we keep getting older. I digress. So we have let age equal 30, and we can do console.log, and then we're going to just throw age in there. And then what we can do is say age plus. Now this is a shorthand, and we'll get into all the long ways to write this, but what this does is that it increments this number by 1. And if I just hit Control-C, Control-V, that will duplicate the line, and I can hold down Alt on my keyboard and arrow down to move console.log age to be right below it. Now when we run this, we're going to get 30 and 31. Very nice. Now we are starting to get a lot of console logs, and unfortunately I don't know how to clear them in here. I have a way of doing it, but we're just going to go ahead and comment out the things that we're not using. So for this case, like hello world, we'll comment out, kilometers in a meter we'll comment out, and yeah, this is fine from here. And then if I hit Control-C, this website specifically creates a copy of the code inside of the URL, and I should be able to just hit Control-V. Oh, that didn't work. I meant Control-Save. Sorry, not Control-C, Control-Save, so Control-S. Ooh, that's different. I'm usually on a Mac when I use this website. I'm sure there is a way to do it, but in this case, we're just going to hit the share button, which copies the URL. That is so interesting. Control-V. All right, there we go. And if I hit enter, it's going to load the exact same code up I guess I need to go to a new tab because that didn't actually clear anything. Control V, enter, and there we go. Now we have a clear console log, and we got our code over here. There's got to be a better way to do that. If you know, definitely leave it in the comments. I'll pin you. Because I've been wondering that for a while. How do you clear the console from this? I'm like, I don't see any buttons. But, oh, okay. So, like, I'm actually kind of curious. Is there a console dot? Oh, there is. Are you kidding me? There's console.clear. If only I had looked, I would have found this. So if we hit run, there shouldn't be anything on the console because we're clearing it. Yeah. Okay, well now we know. So now I can remove that, run it. Ha, very nice. So I think what we'll do is put at the very bottom here, console.clear, parentheses, semicolon, and then we'll do control/ to comment it out. So now going back to the very beginning, what we were talking about here is, remember, these parentheses call the method clear. And so if I just did this, nothing will happen. Here, I'll even show it. And I hit run, it still logs those numbers. Whereas if I hit Control Z, add those back in, Control/ to uncomment, hit run, you'll see it actually does run console.clear. And that's because in TypeScript, the parentheses is, like I mentioned, it's calling the method clear. And if I remove the parentheses, it's actually just a reference to the method clear. And this is definitely on the more advanced side, but just so you can kind of get some idea of why you can have references, it's because you can do this. You can say constant clear equals console.clear. And if you hover over this, you can see that clear is a method or a function. This is really just a function, right? And now we can call clear from anywhere. So now instead of calling console.clear, we can call clear, and if we hit run, it's still clearing it. And we can hit console/ and then run. And I guess I'll keep that code there because it's a pretty good example, right? Okay, so I wanted to mention, like, what is a method and what is a function? And a function is something you can create. It's pretty easy. You just type function. We'll call this function print. I want to do something more advanced, but let's just print hello world, right? Like, really simple function. Okay, this is what a function looks like. So you start by declaring that it's a function. You say the name of the function. These are the parentheses, which is where parameters will go. We'll talk about that in just a moment. And then these curly braces is the function itself. This is what's going to happen inside the function. And so in this case, printing hello world would be this line from up here. So in fact, I think we'll move this down and in and hit control/, oops, control/, there we go. Shift-Alt-F is going to reformat and beautify your code. So that's what I just did there, Shift-Alt-F. And now that we've got this function for print hello world, and we have everything running just the same as before, if I hit run, you're going to notice it doesn't print hello world. It's because even though this function is declared, it's not actually being used. That's actually what's happening right here with clear, right? Like, we're declaring this function clear, but it's not being used. And so what we need to do is actually use the function. And so we just call print hello world. And remember, we have to use those parentheses to actually call the function. And then we'll hit run, and now it's printed hello world. Fantastic. Once again, we're going to go ahead and comment this out since we're not using it at this moment. And we can expand upon this in many ways. Let's start by clearing. Run clear. There we go. Control/. And what do I mean by that? There's a lot I want to talk about with functions. And I think we are ready to get into it, right? Like, we've talked about const, we've talked about let, we've shown that you can change the value of a let. Now, if you do have any JavaScript background, it's important to note that TypeScript is it's trying to be as safe as possible. It's all about the types. And so when I declared age, it says age is a number. This means you can't change it to be a string. If you were in JavaScript, sure, you can, but you can't do that in TypeScript. That's what leads to having bugs, right? So as an example, console.log age, we could say, or we could try to say age equals, oh yeah, this is what I wanted to talk about, this one right here. So yeah, we'll come back to functions in just a moment. Let me put a comment down here to remind me. So we're going to talk about functions versus methods. It's a really deep topic. That's why I don't want to talk about it just this second, because it's quite deep. And then there's also, we need to talk about the parameters and returning values. Okay. Okay, so we got that reminder for later. And so here, if we go to age, and we've said we have the variable age and we want to set it to be something, which is using equals, we can say let's try to set it to the age 31, which is a string. And now you're going to get this error that says, no, it is a number. Now, if you want it to be more than just a number and you want it to be a number or a string, so you could do this for whatever reason, what you do is up here on your let, you can actually tell it what types you want it to be. Right now, this is type inference. It is inferring that this is a number, therefore this variable should be a number. Same thing's happening up here with this constant, although a constant can't change, so that is what it is. But anyway, for our let, we can declare it to be a string or number by saying colon, and this is now where we're going to declare the type, number, or is a up and down slash. On a US keyboard, that's the top right of your keyboard, shift, and then that one right below backspace for me. And so we say let age be a number or a string. And now this has no problem, because as we hover over age, you can see it is a string or a number. And with that set up, we can run this again, and you'll see, oh wow, look at 30, 31, very nice. You could imagine having some sort of way to look up the variable, like the string value. I don't know that I would ever recommend doing it this way, but you might have a use case for it. And there definitely are use cases where you need to have different parameter types on something, but it does lead to other issues, like if you have an if statement. That's something we need to talk about. If statements. If statements. We'll do if, else, if, and else. There are so many really cool things to talk about. And there were some other ones here. Oh, I mean to use the control slash so that it adds the space for me automatically. I want to just like try to keep track of my thoughts, because there's so many awesome things to talk about. If, else, if. There's technically like a switch slash case that we could talk about. I had something else pop into my mind. I guess I'll have to come back to it when it reemerges. We're going to talk about very briefly, which is really down here as part of this functions versus methods, which is classes. Classes is pretty important. And we should also talk about types at some point. We'll put types right here. Okay. Whew. I think that just about does it. Just like really trying to make sure I've got it all covered. So I do want to leave things in here. But yeah, so we got this console.log h++. Oh, this is what we need to talk about right now, which is the different ways that you can change a value. So here you're seeing we use equals. Well, let's duplicate this line, Control-C, Control-V, Control/ this top one, just so we can save the example. And we're now going to remove this declaration so that it can only be a number again. And I'm going to Control/ this one more time, and then Alt arrow this up so that we can like leave that note here. So ideally, we can maybe take a screenshot of this all when we're done or something. So we got our let age equal 30. We got age ++. We console logged it before and after. And we want to discuss other ways that you can increment age. Oh, I just remembered. We're definitely going to need to talk about Control/for. I just remembered the thoughts I was having earlier. They just came flooding back. For loop, for each, a while loop, and we should also talk about, oh my gosh, did it really just jump out of my brain that quick? The for loop. Oh yeah, async. we're going to want to talk about async slash when does the thing happen, which I wanted to expand on in Horizon. For reference, I did a lot of coding without really understanding what I was doing before I joined Horizon. And then in Horizon, the practical use of like seeing when the thing happens is really what unlocked me as a coder. And so I thought this is an important topic to discuss. But like that's a personal experience. Obviously, like what unlocks you as a coder could be very different. Okay. So we've got our age plus plus. Other ways to write age plus plus include age plus equals 1, which says we're going to add 1 to age. You can also do age equals age plus 1. And so these are just progressively getting larger and larger in length. But there's a reason for each of these that makes them incredibly valuable. For instance, if you need to add more than 1, you might want to add 2, okay? And what if you need to do something else to this value? Like let's say, for whatever reason, this age cannot go above 100. If it goes to 100, it's supposed to like stay at 100. We can then do math.max, or excuse me, .minimum. And now what this is going to do is it's going to choose the minimum of 2 values. Now it is a method of math, which means we need parentheses. So I've already added the parentheses. I'm going to add another set of parentheses just so it's easier to read. I can do that by holding, highlighting the whole line of code that I want to surround in parentheses. This also works for quotes, single ticks, backticks, and quite a few others. But you just highlight and then press the beginning open brace, so open parenthesis, and that's going to put parentheses around the whole thing. And the reason we're doing that is because minimum takes 2 values. It looks like you can have as many as you want, but in this case we want to know what is the minimum between age plus 1 and 100 so that this value can no longer go over 100. And so as you can see, there's just different ways or different times and places for each of these. Now this is the one that makes the most sense for a value like age. Plus 2 might make more sense for something like score or health, which would actually be more like minus equals. So you can imagine there's a minus minus, there's minus equals, so on. We're going to go back to plus. And then there's all sorts of various ways you might want to run math on the value before setting it. And that's when you want to use your equals, which is basically like a set 2. Okay. So I thought it might be fun to quickly demonstrate this max or this minimum, which sets a maximum. Because what minimum does is it selects whichever is smaller. So when it goes above 100, the 100 becomes the maximum because it's the minimum. I know it's confusing. It breaks my brain so hard. But let's quickly demonstrate this by using a while loop. So we're going to say while, and this is just a really easy one to write. This is why we're doing it. So we're going to say while age is less than 200. So we're going all the way. Well, it's never going to reach 200, is it? Let's do something slightly different then. We're going to then do a for loop. So a while loop is great if your value actually does hit the target. But in this case, we want to run 200 iterations of age plus plus. And so we're going to say for parentheses. And this one just takes like a lot of writing it to remember how it works. But you just write let I equal 0, and we'll run through this one more time in just a second. Let I equal 0, while I is less than 200, I plus plus, curly braces. So you'll notice some familiarity here in terms of like being more like a function, right? So this is seemingly similar to function. There's no name for it, but you've got these values and stuff is happening in here, right? Then you've got the open curly braces, which is where the stuff is going to happen. And so in here, we want to do a console.log of age. So I'm going to alt arrow this up, shift alt F to prettify it. And then last right here on 18, we want to increment age. So if I do age plus plus, and we go and comment out these 3 examples, so control /. I think this is a good moment to show you another version of commenting, which is /*, and then you can do */, and that comments out this section. So that's another way you can comment if you don't want it. And I don't know if this works with the control slash. It does not. So I tend to use control slash because it's pretty easy to comment out a section and uncomment a section, but there is this star thing if you ever want to use that. So we'll leave that example in there as well. Okay, so what I want to do first is run this code. We're gonna remove this. We're gonna comment out this console log. And now what we're gonna see is the age is gonna go up, 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 and it's gonna stop at 200. So let's go ahead and hit run. And here we can see, oh, it goes to 230, right? Because it starts at 30, that makes sense. And you'll notice something weird happened. Oh, that's from before. So it starts at 31, that's what I wanted to show. Because right here the value is 30, then we added 1 to it before console logging it, which is where if you really want it to show that first value, you need to have this console log before the for loop. In this case, we're not concerned about that, but just kind of like if you're building something and you need that, that's pretty common. You could also set this to be 29, just be starting at 1 less. It really depends on your use case and what you're trying to do. Okay, so now that we got that set up and it goes all the way to 230, we want to limit it to 100. So what I'm going to do is Control-C, Control-V this line of code. I'm going to hit Alt arrow down, Shift Alt F to put it in place. We can then delete this line. And now we'll remember that age equaling math.min, age plus 1 is incrementing age right here. This is where it goes up by 1. And then this minimum is going to keep it within the bounds of 100. And there's quite a few other math things. So just to quickly show you that, you can hit dot to get a drop-down list of all the options under math. This works for a lot of things. But here you can see there's also a max, which isn't surprising. You've got sine waves, you've got square root, tangents, random. Math.random is really common. We should definitely talk about math.random at some point. But yeah, lots of math functions. Absolute value is also super cool, super useful. Pi is in here, etc. So lots of cool math. I'm going to put a note down here at the bottom to talk about math.random. Random. There we go. Now that we have this set up, it's time to see if the code works. Let's quickly make sure, you know what we can do? This is actually so brilliant. Let's move this code all the way to the top. So let's see if I can get that to work. Alt arrow up. There we go. And is there enough space there? I like to have a little bit of space between kind of big important things. Like right here, having 2 spaces makes sense. And I think I'm going to remove that space to kind of keep those correlated together. And same thing here, since we're starting to get quite a bit of code here. And now that we've got this console.log age ready to run, we've now got this clear at the top. If I hit Control/, we are now going to clear our console every single time, which makes so much sense. So I don't get that confusing bit at the beginning anymore. So we're going to hit run. And as you can see here, we have lots of 100s, but it starts at 31, as we mentioned, and it goes until 100, and then it just stays at 100 right here. And that makes sense because we're running this for loop 200 times, so 130 of those times are 100s. Okay. Now, if you wanted to stop at 100, that's where a while loop might come in play. And so if we just Control/ comment that out, and instead write, oopsie, I accidentally full screened it. There we go. And if I create a while loop instead, we could say while, parentheses, and this one is going to allow us to do something really easy, which is just say age is less than 100, curly braces, so very similar to a for loop, right? You have kind of like the parameter of what we're whiling. So we're going to do this, we're going to loop this until age is greater than 100. And greater than or equal to 100. Notice that this is not less than or equal to. This is just less than. Kind of want to talk more about that. There's so many topics. But for this while loop, we're going to say age plus plus, just like before, and console.log, parentheses, age, can see my life passing before my eyes. So then if we hit run, what we're going to see is this goes up until 100, and then it stops. And there we have it. And what you'll note here is that in this case, we're adding to age before, but what if we add to age after and we still want it to go to 100? So that was Alt arrow down, just a reminder. You can Alt arrow key to move things. And so we do the console log first. Now we're going to start at the current age, 30, and then we're going to increment. And if I run this, you'll notice it only goes to 99. If I want it to be inclusive of 100, I need to use the equal symbol. So we say age is less than or equals to 100, and we hit run. Now it goes all the way from 30 to 100, and if there's any other logic you need to do, that would happen between these two things, right? Okay, so the order is kind of optional. However you want to do it, you can increment age before or after. Just noting that if you are incrementing afterwards, and we do a console log afterwards, it's now Shift-Alt-F, and we run that. You'll see it is actually at 101, right? Like the value does go above what you're seeing via this console log. So that's a big reason why you'll see me do it ahead of time and then put the console log ahead of it like this. That's really why I do it. So it makes more sense. Because we had less than or equal to, we need to change that back to less than, then hit run. All right. What did I miss? Oh, maybe I just didn't wait long enough. Yeah, I probably ran it too soon, so the code hadn't finished compiling. Which I guess is a quick thing we can talk about. So you see this flash that says compiling when we change something, right? Does it? No. Well, anyway, compilation is something that needs to happen. TypeScript needs to be compiled before it can be run. So there's that brief blip. And in Horizon specifically, that blip can take about 5 or 10 seconds. So when we get there, there's definitely a little bit of waiting. Then we can run our code. Okay. So, I see how that Control S works as long as you're in this code area. If you're outside of the code area, because it copies the, it makes sense now. Okay. So Control S to copy the URL does still work. Okay, so with this done, we are going to Control/ so that we comment that out. We no longer need to console log 100 numbers or 70. And we've basically covered all of those. We've covered 2 different types of loops. As I mentioned with the for loop, I really do think this is just something you gotta kind of memorize. It's a very common pattern for for loops. I don't use for loops that often, and I don't use while loops that often either. I tend to use a for each, and we will get into for each in a minute, but we're not there yet. So, we need to talk about arrays too. So let's add that to the list. I'm gonna put array and for each kind of in this same category, because for each allows you to go over an entire array. Like you'll be able to loop over the entire array or an entire map. And so since we've done most of this and we've written down the rest, we can delete that one. Okay. So let's see. This is starting to get a little bit convoluted, isn't it, with all this code in here. I think we can more or less comment out everything we're not using. So we're not using the constant right now. We're still clearing at the top. That makes sense. Thinking we can now comment this out, and this is all kind of related, so we'll just put it next to each other. Although I'll keep some space right there. Trying to clean this up like I would my mind. At least that's the idea. Okay. And I think that will do. Whew. Okie doke. I guess there was one last thing I want to say about the for loop, which is, what are we actually doing? Well, we're saying we're going to create a variable I. So this doesn't have to be called I. You can give this another name. There's a thing that we often do, which would be for let x equal 0, while x is less than 10, x plus plus, curly braces, And then if I copy this code, Control C, and paste it here, and then Shift Alt F to prettify it, you can see that we can actually nest for loops, and then we iterate over the y value. And so you'd say x and y. And so if you were doing something on a 2D plane, this might be something you need to do 10 iterations for each direction, right? So now this is a 10 by 10, so this will run 100 times. And we can do that one more time, Shift Alt F, and change that to Z. So if you needed to do a 3-dimensional space, which would be 1,000 times, you can do that as well. And so these kind of nested for loops can be very useful in certain scenarios. I think most recently I used it to build like a maze generator or a dungeon generator where you need to have a certain number of tiles. So I'll leave that commented out as well. Because, yeah, so that's what we're saying here. So we're saying I is what we call, it's an iterator. So I stands for iterator. So we say let I equal 0. So it starts at 0. Then I is less than 200. This is how long we're going to run this loop for. And then we increment it right here by saying I++. All right, I think that fairly well explains the for loop. Continuing on, and these are all the things we still need to talk about. So let me move this one up so that it's with the others, and with the other like bits we've already done. And oh, we had the print hello world right here. We'll move that up as well. And we'll comment this out as well, Control/. There we go. So next up, let's talk more about functions. So we've done this print hello world. So we know a function is this, and we can create more types of functions. So instead of printing hello world, let's print a string. Print a string. And then parentheses. Now, this parentheses allows us to receive parameters. You've seen this before, right? When we call console.log age, we are passing in the parameter age, and it is logging that number to the console. And so print a string allows us to say some string, this is the name of the variable, and what is it? It is a string, so we declare the type, which is why I'm not doing string. So in this case, some string is just, you'd want to have a good name for it. We might say string to print, right? And then we do curly braces just like before. And then we can say console.log parentheses string to print, right? And now this function is going to print anything we pass into it as a parameter, but that parameter has to be a string. So if we do, we call print a string, and then we pass in the parameter hello world, that's happy. But if I do print a string and I pass in the parameter 99, it is unhappy because that's not a string. Now you'll remember from earlier, we have a way to convert values to a string by doing dot to string. Oops, Control to string. And this doesn't work on all values. Pretty much thought that was going to work on this value. To string, did I spell it right? I'm pretty sure that was going to work. Parentheses. Parentheses. Interesting. I guess it needed parentheses around it. Don't have a great explanation for that, but seems like adding parentheses around this number allowed us to call dot to string. I could swear we did it earlier without using. Oh, we were able to do it earlier because it was a variable. We were doing it on meters in a kilometer, which is basically like putting parentheses around it. So if you have a raw number value, that makes sense. Okay. Anyway, if we go ahead and hit run, you'll see that hello world and 99 get printed to the console. Pretty nice. Okay, so with that, we'll go ahead and comment it out. And there's one more function type that I want to show you, which is, let's move on down some more. Function, and this function is going to return a value. And so it's going to say how many meters in a kilometer. This is a dumb function, but we're going to do it anyway. So you don't have to pass in a parameter to find out how many meters are in a kilometer. You get back the number of meters that are in a kilometer. And to return a value, we use colon, and we say, what is the return type? It is a number, and then curly braces. And so what this function does is it returns a number, and we need to then uncomment our how many meters are in a kilometer right here, so control /. And then we can now return a number by saying return meters in a kilometer. And now this is all happy, right? It was unhappy, it was red when this was not in here because you have to return a value. This function is required to return a value. And that's that type safety, just trying to make sure that everything does what it says it's going to do. Like technically I could delete this, and then if you hover over it, it does add that behind the scenes. I don't recommend using this inference based off of returns. I absolutely recommend making sure to write this in. It's just like if you have a mistake where you're returning a string rather than a number or something else, like you just could accidentally make mistakes. Like this very much clarifies your thoughts and what you want the function to do, so you're less likely to create like bad code that's going to create an error later down the line. Okay, so function, how many meters in a kilometer? Returns a number, and there we go. And now this doesn't have to return a number, right? Like this could return, or it doesn't have to return a static number like the number of meters in a kilometer. It could return the age or something else. And you know, you could have, as an example, I'm not going to write this code, but just as an example, you could increment a number, and then it could return how many times the function had been called. So it'd be like, how many times was this function called? And it would say, yeah, that number is 25. I think, you know, I said I wasn't going to do it, but I want to show maybe an example that makes a little bit of sense. So you might say function, and because this is a pretty common thing that you might see when you're coding, print string, or we'll call this log string, and then parentheses, it's going to take a string like before, so we'll call this string to log. I was using print up here because of it's C#. I believe we call it print in C#. Like not even sure at this moment because I switch between language too frequently. But anyway, string to log, since we're in TypeScript. And then this is of course a string value just like before. And now we can do console.log string to log just like before. But what we can do one step higher than this is also return a number. And then we can come up here and create a variable called let number of strings logged equals 0, right? So now we have a number to know how many times have we logged strings. And then after logging the string, we can say number of strings logged plus plus, and then we can return the number of strings logged. And the reason that this is a common thing you're going to see when coding in TypeScript is you often don't need this number of strings logged or whatever it is for that function that you're calling, but it offers this opportunity to get that value. So when you hover over log string, it's going to log the string, but it says it returns a number. Now the problem with this function is you don't know what this number is when you read this hover over. And so we can create good hints. So code hints can be created. And so when you're writing code and you're writing code to be like, for others where it might not be entirely clear what the function does, you can do /**, press enter, and that should have, I guess, usually in VS Code it automatically fills that out for me. It doesn't seem to do that here in the TypeScript Playground. But anyway, you can then explain what the parameters and the return types are. And so you can say logs a string to the console, returns a number, returns the count for number of strings logged by this function. Right? And now if I hover over log string, you can see it now has a comment here that says logs a string to the console, returns the count for number of strings logged by this function. I'm actually going to have to Google this real quick because I don't remember exactly how it looks. So I want to say TypeScript code hints for function. It's like an @ symbol or something. Let's go to images, and somebody's got to have a good one in here. And really, no good ones. I guess because code hint means something different than what I thought it meant. I mean, what do they call those? Code hints. TypeScript code hint, writing my own code hints for function. Genuinely thought, oh, there it is. Here we go. Okay, so you can see here it says @default hello. That's what we're looking for, this @default. But it's something like that. Is there anyone else posting similar? This might be faster to go look at my own code to find this. Normally, normally VS Code will fill that in for me, and so I don't actually have to do this. Oh, function declaration. There we go. And here we go. This is exactly it. Okay, @parameter. That's what I was looking for. @parameter. The name of the parameter, and then what it does. So if we go back in here, underneath, so this first line is the description, and then we would say @parameter, and then we have the string to log parameter. Nice. And then we can say, what does that string to log parameter do? And then we can say the string to log to the console. And then if we hover over, you can see @parameter string to log, the string to log to the console. And then I believe you can also type return. Maybe it's like @return. Returns, @returns. And then we'll just, there we go, Control-C. Returns number of strings logged by this function. If I hover over this, @returns number of strings. Okay, perfect. Okay, exactly. That's, anyway, normally when you type /** enter, it does fill these parameters out for you, so you don't have to do that. But there you go. That's how that works. Okay. So, yeah, I hope that helps. There's obviously a ton we can talk about, so I'm going to go ahead and leave that one there. And we are going to go ahead and turn off meters in a kilometer now, since we're not using that anymore. We could call this function and do something with it, right? So we could say, yeah, I guess showing how to use this since it's kind of complicated, right? So you might need to know, so we'd say constant current strings logged equals, and then you would call log string parentheses, and then the string you want to log, which might be something simple like hello, and then you might say console dot log parentheses number of strings logged. Oh, current number of strings logged. Control-C. Control-save. Now normally these would be divided into like separate files, so there's less likelihood of you pulling the number of strings logged, but anyway, I digress. So we've got the hello, and the number returned was 1. Very nice. Control/ to comment those out for now. And that covers functions. Now we did talk about parameters, and we did talk about returning values. We now need to talk about methods. You're going to hear me say that a method is just like a function, except it exists inside of a class. And there are a lot of basics still to talk about, so we're going to get there. But let's move this one up right now, because this is what we're going to talk about. And I don't recommend making classes very often. Hello again. I don't recommend making classes very often. I did when I was starting out because I'd come from Unity C# where we were making classes all the time. It was kind of like the fundamentals for C# was you needed to build classes. But in TypeScript, you don't really need to do that. The main reason you would want to use a class is if you got something that's needs like a method, like there's some sort of functions that are really valuable there. There really just is not. I would say I haven't written a class in over a year because my mentor Waffle was like, I don't like classes, and I was like, but I love classes, and then eventually I realized, oh, he's right. There's really no need for them, and I can't think of a time in the last 9 months that I've used a class. So again, I don't think you really need them. There definitely is a case for them at some point, but so I'm going to show you. Wait, one more thing there. I'm going to show it to you because Horizon centers around using a class, but not you creating the class. The class is already created for you, and there are tons of classes that you will use. So it's valuable to understand how a class works and how to make one, but it's not something that you actually need to make on your own. I think that makes sense. So I'm trying to think if there's anything else there. Yeah, I might change my tone on that at some point, but for now, that's my current line of reasoning. Okay, so we're going to say class, and this class is going to be called I'm building this for you guys, my students. So the class student, and class student curly braces opens up. So in this case, we capitalize it because it is a data structure, and inside of this, there are different values that a student might have, right? Like you might have the year, right? Like the year. So it'd say private year and is of type number. All right. And so we're saying what is their year? We'll call this grad year because I feel like that makes the most sense. So a student has a grad year. Now you'll notice that this is upset because it's not initialized. So what we need to do is figure out how do you create a student, and we do that. And I'm going to go backtrack and walk through this all one more time in a second, but we do that by using, oh my gosh, constructor. It's been a minute. And so the constructor is going to take a number, which is the grad year. So we say grad year colon is a number, and then we curly braces, and so constructor receives a grad year, which needs to set the value grad year. So then it's going to say this dot grad year equals grad year, which takes the grad year up here and it sets it. So this dot grad year refers to self, the class, and then it sets it to be equal to this grad year, or excuse me, this grad year that came in as the parameter. Okay. So now that we've got this constructed and the errors fixed, there's so much here to talk about. So I guess we should pause and talk about what's going on inside this. Okay, a class is something that can be assigned over and over and over again. It's like a template. It's reusable. And so let's say we want to create a student. I'm going to create a student based off of myself, so I don't offend anybody. So we're going to say constant lakes is of type student and equals new student. And then parentheses, my grad year was, depending on which year you're talking about, but basically let's go with 2012. There we go. So here we've said Lakes is a student. And so now you can see that this Lakes exists as a student. You don't need to declare the type student. It is inferred by using the equals new student, so we can remove that. So this is just a little cleaner, easier to read. It is insanely important that your code is readable. So if it's not clear that Lakes is a student, maybe try to make it clear. So like Lakes the student. That is not terrible. But now that we've got that set up, we could duplicate this again. And I'm going to pick on my friend Flex and say Flex the student. And I think he graduated probably the same year as me, or maybe the year before or after, because we're about the same age. So Flex the student. So Lakes the student, Flex the student. But now we need a bunch of students. We have multiple students, so we should add them to a list of students. And so what we could do is say constant students, and I'm going to say equals an array. And now this is going to get a little complicated, so we'll come back to this one because we haven't finished talking about classes. So this is a student array, and I'm going to just comment this out for now. Control slash. We'll come back to that. Okay, so we've created two students, right? Like they have the same grad year. That's cool. So a class is this reusable template, and it's allowed us to create two different students. And this private grad year is private, meaning if you go to Lakes, the student, and put a period, there is no grad year. If I make this public, so yeah, it does allow me to do that. I think public is the default. So if I do Lakes the student dot grad year, now you have access to my grad year. Now if I go back and delete that public, I believe it's default public. Yes, that's correct. And that's why I added private, because I don't want this to be public. I want this to be hidden. And I want the way that you access grad year to be constricted. Now, before we get into that, because that's complicated, the constructor is how you initialize a student. So when you say new student, you are calling the constructor with those parentheses because you're creating that student. And there's certain values like grad year. There might be age, name. Like actually name makes the most sense, right? So let's go and do a private name, which will be a string. And then we need to put that as a parameter here. So let's put that at the beginning. And I like to think logically. Like I try to organize my code and my thoughts, like in what ways that I feel like make sense. So like name seems to like it should go first. So name is a string, and then comma. And then you'll notice, okay, now we've got an error down here because this doesn't provide the name. So I'll do single ticks, comma, and then Lakes. And so what we've done here is we've added a secondary parameter. So we've got the string parameter, comma, and then the number parameter. And so down here we pass the string parameter first, then the number parameter, and order of course does matter. Let's go quickly add the comma space first, and then single ticks should double up, which is nice. And then we can type flex, or flexed. We'll just call him flex for now. Sorry, flexed. Flexed. I don't know, I'm embarrassed. I don't know. It's shorthand, it's cute, it's sweet. Anyway, we're gonna go with flex. Anywho, we've got Lakes and Flex, and we've created them. They both have names. Why is that? Oh, right, we need to set the name value. So just like we did with grad year, we need to say this dot name equals name. And so in here, this can feel a little confusing, but when we create this new student, it's like when you're inside of it, this is referring to the student itself. So like Lakes the student, if you're running code inside of it, inside the class, this refers to everything happening inside of Lakes the student. And so this is saying this dot grad year for Lakes, because we've just created the Lakes one first, right? And so it's saying this dot grad year for Lakes is the grad year provided. This dot name for Lakes is of course Lakes. And then Flex has its own values. So you'll see this template allows us to basically give each of these variables all of those properties. Okay, now to access those properties, you could make them public like I showed, or you can do an in and out, which I'm not super, like I said, I don't do classes very often, but there's, if I'm not mistaken, Typescript. Actually, you know what? This is a good example of when ChatGPT is super useful, which is where you need it to just like show you something really basic. And so stay logged out. We're going to please add a get set for my class private variables. And because I don't remember exactly the easiest way to do this, this should show us the easiest way to do it, which is a great example of when to use ChatGPT for basics. If you ask it for anything complex, it's usually wrong. This getter and setter is way more complicated. Like this is what I would have wrote without knowing. I assumed there'd be a way easier way to do it. Oh, maybe get set. This looks better. Oh, this looks better. If you prefer using, yes, this is of course what I wanted. Like, why would you even offer that? Okay, so yes, this is what we wanted, and get name string return this underscore dot name. Yeah, so this is a little bit complex, and like I said, you're not going to be using this, but what this is doing is it's my brain. I'm like trying to figure out how do I explain this in layman terms. Why don't I show you how it works? Because that's really all that matters. And in fact, we're just going to copy this code because ideally you never have to write this because you're not creating classes. And I'm really just trying to show you how to understand what classes are and how they work. Okay, so name is now conflicting with this name, which I assume they'd renamed up here. They used underscore name. Yeah, that's the standard. And so if we add underscore name, underscore grad year, we can then change these to be underscore and underscore. And then what this allows us to do is we can get the name and set the name without like directly accessing the private value. The reason you want to do this is so that if you ever need to like find a bug in your code for your class, you can use a console.log inside the getter or the setter to figure out what's going on. And so somebody might be passing an invalid value somehow, and this allows you to check for that and figure out what's going on. Whereas if they had direct access to the name, then they're going to be changing the value, and there's no way for you to debug it without like a lot more rigorous code changes. So here we had Lakes the student, and we can now say dot name dot get, right? Oh, this is so much more beautiful. So sorry. So in Horizon, you're going to see things that literally are dot get dot set. That's because they're integrating with, this is like, we're getting way too technical, but for those nerds like myself, Horizon is built on Unity, and Unity uses C#, and C# tying into TypeScript needs a .get .set for it to actually work, which is a lot closer to what you see in the first example that that they gave. The one that we did is actually the one that you should do if you're ever implementing this, because you don't have to tie into C#. When tying into C#, they do what's called a bridge call. And anytime you see that .get .set in a Horizon API, it's slowing your code down. And there are some risks there if you start doing thousands of operations using .get and .set. If you're only doing a few, you probably don't need to worry about it. But when you get up to those upper levels, you're going to want to start optimizing your code to like store variables locally and then set the public, use the .get and .set like once a second rather than 1,000 times a second or something. I think we should abandon this tangent and just wrap on classes, because everything I've said still holds true. You probably won't need to use these for most things. And they are really cool though. Like there's a lot of cool stuff, but it's really not something you need. So the way that we've written it is way more optimized, because we can actually just say name equals and change the name of Lakes. Oh no, Lakes' name is Alex? No, there is no way. And so then we can do console.log parentheses Lakes the student dot name, and then we can do that before and after, Control-C, Control-V, Alt-arrow, and then hit run. And we can see, oh, Lakes is Alex now. Like, we changed his name. And the other thing that we could do is, of course, print the grad year. So we could say plus, and we do maybe like a comma, graduates in, or graduated on, and then plus Lakes the student dot grad year. And because this is directly inside of console.log is going to handle changing that number into a string for us. We can now hit run, graduated on 2025, in 2012, whatever. But you get the point. So, cool. I don't want to dox myself, so I'm actually going to just change this. When I was in school, in very early elementary school, I had the nickname Axel. There we go. Don't you dare ever call me that, though. I am Lakes. Thank you very much. We've been remixing my name for a very long time. That's all you need to know. Okay. Yeah, so let's get back to this idea of having a... Oh, wait, there's one more thing we need to talk about with classes, which is you can create custom functions. And these custom functions could be super useful. You can, of course, have a private function, which could be... I guess we're just going to keep going with hello world. Makes sense. It makes sense for a demo like this. So you could have a private hello world that does console.log parentheses hello. Oh, hello from... Oh, we got to put single ticks around this. Hello from inside of, and then we'll do plus underscore name, right? This dot name, name, underscore name. I feel like we probably should use that one. That makes sense because of what we talked about for safety reasons. Okay, so hello from inside of the Lakes, and then plus class. There we go. All right. So now we've got this hello world that prints a little bit more detail, and we can then make a public that says it's automatically default public, so we don't need to write public. We just say hello, parentheses, curly braces, and then that's going to call the private hello world. So this dot hello world. There we go. Remember, we need these parentheses anytime we call a method and anytime we create a function. And so inside of a class, it's called a method. So functions, methods. I use the words interchangeably sometimes, and that's totally okay. You should know what I mean. But from a technical standpoint, it's a method if it's inside of a class. It's a function if it's created outside of a class. There we go. Okay. Let's go ahead and come back down here. We're going to comment out this code, Control/, and we're going to instead say, I really enjoy the idea of making Flex say hello. So we're going to go inside of Flex. So sorry, Flex. Flex say hello. And then we'll go ahead and hit run, and it says hello from inside of the Flex class. Very cool. And yeah, that is the basics, right? So you can have functions, you can have private functions, or methods, in this case is what we call them, and that is how you create a class like student. Now, there is one more thing we could do with classes. I'm going to really quickly construct a class that is already constructed inside of Horizon, and then we're going to come back to this. Yeah? Yeah, okay, very, very quickly. I'm going to try to remember to come back to that. It's going to be hard. I'm going to have to do something special here, like some stars or something. Yeah, that'll do it. So there's a class in Horizon called Vec3. It's your Vector3 class, which if you're not familiar with the Vector3, you're going to be very familiar in just a moment. And so we create the class Vector3 just like we did with student. And Vector3 has 3 private values, X, Y, and Z. Now I'm just going to make these public just for the simplicity of like making this thing and getting it done fast. So we're going to say X equals 0, or excuse me, X is a number. So we say X colon number and semicolon, Y colon number, Z colon number. So we've created an X, Y, and Z value. You're starting to see what Vec3 refers to. It's a position in space. It can also be a scale. It can also be a distance. This is 3-dimensional numbers, right? So X, Y, and Z represent typically coordinates in space. And so we need a constructor. The constructor is going to receive an X number value, a Y number value, and of course a z number value. Now there are easier ways to initialize these three values through the constructor. I'm not going to show that today. I think that making it verbose and making it easier to read is much better than making it concise and harder to read your code. So we're going to type this dot x equals x, and then we just do that again for y and z. So this dot y equals y, this dot z equals z. Okay. Now that this has been set up, we can create a vector3, and I'm not going to create all the methods that vector3s have. They've got a ton, like normalize, magnitude, lots of good stuff. We'll get into those in other tutorials. They're awesome. I love math. But the thing that I wanted to show you that classes can do is they can have a toString method, and the toString method, of course, returns a string, and it converts this whole thing into a string. And so the shorthand for this is to type return, and I'm not great. This is one of those things where I think it's important to remind people I'm human. I can only know so much, and there's certain things I do differently. And so as a human, I'm going to show you something else that I think is super valuable, and I think every one of my teachers would be like, you have to show this, even though it's not something that I'm good at. So without further ado, this Control-C, we're going to go back to our ChatGPT because it's really good at showing basics, just like we said before. And so I'm going to say, can you implement the toString on my vec3 and fix that, please? Thank you. Okay. And send. And what you're going to see here is that it's going to use a special type of notation that creates a string. And this is a notation that I just do not like. I find it very hard to read. But we're going to just go ahead and copy it and break it down over here. All right, so what this does is it starts by using a backtick. And by being inside of a backtick, you can actually use this dollar symbol plus some curly braces. Oopsie, get me out of that. What did I? There we go. By using so let's write this ourselves so it makes more sense. So we type return and single ticks vec3. So this is just saying that this is a vector3. And personally, I actually wouldn't put this in my console log. Well, might put like vector. You know, I'm not even gonna do that. I would personally not have that. And instead, I would do, I think parentheses is fair. And then inside the parentheses, we need to include these values. So the parentheses are like typical string values. This is upset because there's two return types, Control/. And then inside the parentheses, we need to have the values comma separated. And so you can type $, curly braces, and this allows you to input the variable that you want, in this case, this .x. And then after the curly brace, you can add a comma. Now the comma is back in string land, and then we can do a space, which is also in string land, so to speak. And then $, curly braces, now we need another variable, this .y, comma, $, curly braces, this .z. And by doing this, I'm actually feeling more comfortable here than I've ever felt before. I still don't love it, but what we can do to show how this works is we can create a vector3. So we can say constant 0vec equals new vec3 parentheses 0, 0, 0. Remember Shift-Alt-F for prettifying adds the spaces for you, which is nice if you don't want to type a lot of keys. And then we can type console.log, and this is why we use a .toString method and why I'm bringing it up, is if you do end up making classes using toString, the console does it automatically. So we just type in the 0vec, and it will automatically use this toString method from the class. Run. Oh, right. I have the stars up here to remind me. Run. There you go. And so here you can see that has come through. Not as I expected, actually. Let's try this one more time. Maybe it doesn't work as well as I thought. It's confusing. Oh, that is very confusing. I really thought that was going to work. I must have misunderstood something when I was learning about log, but that's okay. Like I said earlier, I'm human. I make mistakes. How interesting. But anyway, you can call .toString on it, which is also incredibly valuable. And now that I'm looking at this, I am feeling like having vec3 there will make this more readable. Vec3. Let's go ahead and hit run again. Yeah, that does look better. I just feel like in Horizon it's different. Like I feel like it says vector instead. I mean, we only have one type of vector, so it would make sense. But yeah, something like that. Now, how would I have written this? I will show you. It's, in my opinion, easier to read, which is why I do it this way. So I do single ticks, vector3, and then parentheses, and then backspace that parenthesis, and then plus, also this is unhappy because control slash. We can now delete this line. Now we'll leave them both. Okay, vector3 plus, now we need the variable, which we can just type this dot x and then comma, and then we need to add, or excuse me, not comma, plus, and then we need to add the comma, which is comma space, and then plus this dot y plus comma space plus this dot z, and then plus, and then our final is a parentheses, and then semicolon at the end. And I personally find this a lot easier to read. Some people find this a lot easier to read. I think that this is more concise, absolutely, but I do feel like the curly braces and dollar signs kind of get in the way of seeing what it says, whereas this, I feel like I can just read it as I look across, and it's like, oh, okay, got it. So yeah, two different ways to do that. I'm going to delete this one, and we'll go ahead and hit run, make sure it still works, and it does because it's the same thing. We'll change the values to make sure 1 and run. Well, that's strange. X, Y, Z, 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 X, Y, Z. Oh, there it is. It just, I guess it didn't update in time. It was that same bug we had earlier. Okay, cool. Just lag. Okay, very cool. So we've talked about the vector3 here. I hope you find that somewhat helpful if you end up going into classes, but it's also kind of useful to know when you're using classes, which is why we've been talking so much about them, because you will use them a lot. Okay, next up on our to-do list, we are going to have a bag of students. I need to stop using that for arrays. It's an array of students. And what an array is it is a list of items, or it's a thing, I want to say bag of items, but we have a different thing we're going to talk about in a minute, which is actually a bag of items. It's a bag of the same items, right? And so you can hold multiple students inside of this. So we say the constant variable students is of type student array. The reason we use constant is because we don't want to ever swap it out. It's always the same bag, right? Like if we're going to keep going with this bag analogy, we don't change the bag out because if we swapped bags, we would lose all the data inside of it. So it's the same bag of things or students. We're saying it's a student array, and then we start it by being an empty array here. So now there's currently no students. Now when we create students, we can add them to the array. So we say students dot push, and we use push to add to the array, parentheses, lakes the student. And we can then do the same thing, students dot push, and then we can do flex the student. And now we have two students, and now we can do, remember me saying earlier, I don't really use for loops except for in really specific occasions, and same with while loops, because there's this thing called a for each loop. And so we can say students dot for each student, parenthesis, and then the way that this works is we do another parenthesis to have the value student, and there's another value in here called index, and then we do arrow function, curly braces, I like semicolons, so I add one to the end before I click enter. So between the curly braces, I click enter. And this is what this for each loop looks like. It's very similar to a for loop, right? Maybe? No, not really. Um, but what we have here are some parameters. These are the parameters we get for each student. And we're going to loop through every student in the bag, or the array. I'm going to go back to using array. Okay. And so in this array, every student has an index. So Lakes was added first, so he's at index 0. Flex was added second, so he's at index 1. And now that we've got that set up, we can then say console.log parentheses student.name plus, and we'll do the number index at the beginning. Index plus, and then single ticks plus, and then I like to just put a colon space between them. And then we'll, now we've just console logged each student's name, so we know who the students are in this bag of stuff. And you could imagine you might have a function, right? So you might say function log all students, parentheses, curly braces, and then this alt arrow up while highlighting allows us to move it all up, and then shift alt F to prettify, which adds the indent for us. So this function log all students will allow us to go through all the students and log them to the console and show their index. And so if we do, we just need to call that, right? Log all students, parentheses to actually call it. I'm going to comment this out so you'll see that without the function call it doesn't do anything. And then calling it, we get that same code running again. But yeah, you could imagine having a function like this would be super useful so you don't have to rewrite this code. That's one of the premises of being a programmer, is that you don't want to have to rewrite the same code twice. Now don't take that to the extreme. For like basic things, obviously that's okay, but at some point you're going to have code like this where it does quite a bit, and this is a decent amount here. So having a function that logs all the students would be very useful, and you could use it over and over again wherever you needed that, depending on obviously your use case, and extrapolate that to real life. Anyway, so yeah, that's pretty sweet. Let's see if there's anything else here we need to talk about. So we've got the array, we've created an empty array, we've gone through and added to the array. Removing from the array is actually way more difficult than it should be. I feel like that's a topic for another day because it's that complex. Like, it shouldn't be that complex, but I built a utility for it. Just kind of like I was talking about with this function, having something that makes it so you never have to do the same code twice. And you can find that in the description. If you go to the description, there is a link to our Google Drive. And so let's just take a quick look at that code right now. If you go into the TypeScript utilities, you're going to find the array functions. And I'm going to download it so we can view it. Here we go. And it's probably already here, isn't it? Okay, yeah, it is. It's right there. So right click, open, and we don't need to download. Okay. So yeah, you can find this script and then take a look at it. There are quite a few functions in here, but the one that we're really interested in is remove item from array. So here's the function, and this is how you remove an item. So you have, I'm not going to explain this function just yet, but you have the array as a parameter and the item as a parameter. So you pass in the array, you pass in the item, and then it says the item index. So it says array.index of item. And if that item index is greater than or equal to 0, we know that it is in the index, or it's in the array. So if you pass an item that's not in the array, it doesn't do anything. And then if the item index is greater than or equal to 0, we then splice it, which is to remove it. And we remove the item index, the item at the item index, and only one item is removed. Rather than removing like that item and the next item after it, we just remove one, so just the item. And that's how you remove an item from an array. It's, like I said, a little bit more complex. If you know the index, maybe that's a little bit easier, but indexes could be shifting if you're removing items. So it is best to do this where you're getting the index of the item before you remove it, which is why I have this utility. The way this utility function works is just like you've seen before. We have a function with a name, but this is declaring that there's a type T, and type T means that array can be of any type, and that type is an array. So it's saying T is an array, or array is of the variable or the parameter array is an array of type T. That's what I'm trying to say. Then there's an item passed in, which is also of type T, which is the item that we're removing. Okay, cool. This also gives me an opportunity to show you that if you type /** and click enter, it automatically adds those parameters for you. Really nice. Control Z, Control Z, Control Z. But because this is so very obvious, I don't have comments for it because it's pretty clear what it's doing. Okay, we are done looking at that code. Hopefully that helps you. Very nice. Next up. And there's a lot of code on that Google Drive. If you want to dive into it, feel free. There was something else I wanted to talk about in here. We did for each, what was it? There was something else I wanted to talk about. Ah, it was maps. So going back to our to-do list, let's see if I can find our to-do list. Did I have it above here? No, I think it's always been below. We have talked about functions versus methods. We've talked about classes, so we're doing good. We've talked about an array and for each, so we're doing good there. Map is the next thing we want to talk about. And a map is another data structure. So TypeScript is all about data and how do we use it and manipulate it. And you might imagine that every student is mapped to, let's say, a grade. Obviously, we could store the grade inside of the class, but if the class wasn't created by us, so like in Horizon, there's a player class. We didn't create the player class, so we can't just add new values to it. So if we want to store a grade for a player, or in this case, a student, we need to, I'm going to comment this out so it doesn't keep logging names. We need to use some sort of data structure to store the grade matching each student. So now we've created students here, we've added them to the array here, and we're going to go below this and say we're going to create a map. Obviously this isn't the cleanest code in the world. I usually create a lot of different files and I try to separate my code, but I just thought we'll just put it all in one. I don't know. This is almost seeming like a bad decision, but it's okay. So what we're going to do is we're going to type just gotta take a sip of water real quick. Okay. We need to create a map. So we type constant, the student grade map. So remember, the name is really important. So constant student grade map equals a new map. And this is where things get a little different than what we've seen before. We need to declare what type of map it is, which we do by using the less than and greater than symbols. And so inside of this, we say that it is a map of student, comma, letter, so string, and then parentheses. So what this does is it creates a map where we're taking a student and we're giving every student a string value. And if I hover over this, you can see it's of map student string, map of type student string. And then the parentheses creates the map. Okay, so it's similar to creating like a class. It seems very similar to that. And what we can do then is we can set values because currently there's no data in it, right? So we say student grade map dot set, and we can set for the student Lakes, we can set the grade A-. He's a good student, but he's just not quite there yet. And then we can do for flex, so we say student grade map dot set and parentheses flex the student. Now this guy, he is quite the overachiever. A+. I was really tempted to put it in an F+, but anyway, you're very lucky, Flex. Your grade is very high. Just kidding. I'm just having fun, y'all. So we've got our two grades set in the map, and now we can go ahead and get this. And so we'd say console.log parentheses student grade map dot get, and then we pass in the student that we want to get the value for. In this case, we'll get lakes. And when we hover over get, you'll see that it returns the string or undefined. Sorry, my nose is giving me a little swirl. And so the string is obviously the value that we paired to the player, or the lakes, the student, or it's going to return undefined if we didn't set that student up in the map. So what we're going to do is go ahead and hit run, and we can see that lakes has an A-. If we comment this code out where we set it, it's going to return undefined because lakes is no longer in the map. So let's go ahead and undo that. But yeah, that's pretty much it. That's how a map works. You can store value, you can set value, you can get value. You can delete a value. So we can do console. Let's actually do that right here. Excuse me. Student grade map dot delete parentheses lakes, and that's going to delete lakes from the list. So if we hit run, it's still undefined. Control / and run. There it is still. So you can see how that works. Very cool. We're going to comment this out as well. Okay, so that's a student grade map. Now, similarly for student grade map, if I was creating a map like this, I wouldn't use an array because a map basically functions like an array other than the fact that it doesn't have an index. So if I delete students, I can delete this. Ooh, wait, we don't want to do that, right? We want to comment these out so you guys can read them back later. Control /. When we go down here to log all students, we're no longer using students. We can now change this to the student grade map. And we can say the same thing as before, student grade map dot for each. The problem is there's no index, so I'm not sure. Oh, it's not the index. This is actually the value, right? And interestingly, if you look here at this information, I know this is really hard to read if this is your first time, but the value comes first, the key. So the key is the student. So it's like a map, so there's a key. The key is the student, the value is the data paired to that student, and you'll notice it does value first, then key. And so if I hover over student, you'll see that this is a string. This is actually the grade, and this is the student. There we go. And what this means is we don't have an index, but we do have a grade. So we could reverse this, Control X. So we take student name, and then plus single ticks, colon space, plus grade. And so we could say log all student grades, right? And now we can change this Control / log all student grades. Debating whether I should have made two functions, but it's okay. I'll go ahead and hit run, and you can see lakes has an A-, flex has an A+. There you go. Pretty simple, but maps have the same for each ability, and if you're going to have a map, you might as well not have an array because there's not really a good reason. Yeah, and I think there is, like, if you really need an array, it's been a while since I've done this, but I'm pretty sure you can do student grade map dot keys. Yeah. Is that a method you call? Yeah, it is. And so if you take the keys and put that in parentheses, you can say array, and that should create an array from the keys, if I'm not mistaken. And so we could say constant students equals this, and if I hover over that, you can see, oh, I did that wrong. Array dot from, there we go. And so by hovering over it, I can see what it is. So it says student array, right? So array dot from, and then student grade map dot keys gets the keys. And so you'll remember that the keys is the students. We could also get the values and get an array of the values, and now it's a string array. So if you needed an array for whatever reason, you can still do that. We'll go switch that back to keys because keys is usually the one that I would use. And then we'll comment that out. Okay, we're also going to comment that out now. And I think that just about covers our work on students. So there was a lot there. I know. If you haven't started fatiguing it at an hour and a half in, I have. Um, so we're going to keep going because there's still so much more to cover, but I think we're doing really good. We're done with maps. It's now time to talk about JSON objects. Oh, what I was going to say is, if you're fatiguing, consider just hitting the pause button, you know, breathing, go do something, go out and see the world, take a walk, whatever it is you do. Maybe hop into VR, play a video game or whatever. Then come back, maybe even wait a day. I feel like this is just like learning a whole new language. You know, I recently was learning French and I spent 40 minutes a day. I couldn't do more than that, right? Like there was a fatigue point. So if you're at that point, this is a great break point. We're going to do a bunch of basics, which might only take another half an hour. But then I do want to hop in at some point. So like wherever your break point is, feel free to do that. I just think it does help learning if you just let it solidify and then come back and keep going. Okay. I'm just like, one last note. If you haven't heard me say this already, it's one of my favorite thoughts. And when I was in college, there was a teacher of mine who said, the way we learn is you hear it, then you do it or you write it down, and then you review it. And you do it 3 times, right? Those 3 times, that really solidifies the knowledge. So you're going to hear it here in the video. You're going to do it yourself or write it down as your notes, and then you're doing it again. I guess there's the review your code. So I don't know how to say, but basically that's that. I will say at this point that I plan to copy the link. You remember how that was that URL? I plan to copy that URL and paste it into the video description, so that way you can very quickly jump into this. If there's something that you miss a comma or something small, you'll be able to look at the code and just analyze it. Okay. Next up, we're going to talk about JSON objects, often called bags of stuff. And often called bags of stuff. Well, if you're around me, it is. So we previously paired the student grade map to a string. What we're going to do is just come down really far down here. We're just going to get a brand new section. We will be using the students from above because we've already done so much work up there. It's great. But what we're going to do is create a new map. So we're going to say constant map. This is going to be a student data map. So it's going to have a bunch of data. That's what's going to be in our bag of stuff, the JSON object. So the student data map equals a new map of type student. And then there's going to be some stuff and parentheses. Now, oh, yeah, that's right. We haven't defined what this stuff is, so for now I've just put curly braces in, and you can see that it's basically saying that that's allowed. I don't know what to say about that. Sure, you could define what types of data go in here, right? Like, I'm pretty sure you could type grade, string, comma, name, string, grad, year, number, and it's going to allow you to do that. And you'll see that it's now a student paired with this bag of stuff with these 3 values. That's not the most clear way to do it. This is not very clean. And when you create it, it's also not very clean, right? So if you go to, say, student data map dot set for lakes, and then comma, then you have to do curly braces and manually type in all this stuff. So it'd be like grade, and then we're just going to go with that A- again, comma, and then you have name, which we have inside of lakes the student. So you can say lakes the student dot name, and then comma, grad year, lakes the student dot grad year. And like, that works. It's not great. It's really, really not great. So let's make it better. First, we're going to define a basic bag of stuff. So you can do constant my functions equals curly braces and store a bunch of functions in this bag. And we've created some functions up here. I think just log all students. There's a few that are public, right? Log string. So log string, log all functions, and clear are the ones that we've created. So we can just put these inside this bag. So log all student grades, comma, log string, comma, and clear. Those are the functions we've created. And what's nice about making a bag of stuff like this is you can export this, and we can't really do that here. We don't have multiple files, but when you export your bag of stuff, it's available across all of your scripts. And that's a little, like, very slightly a more advanced topic, but when we get into just about any scripts I'm writing have some export somewhere, and I usually export it as a bag of stuff, whether it's a bag of number, like data values, like lets, so that we can change the values, or if it's a bag of functions like this, it's great. And when you call my functions, you now get a drop-down list for all of those functions. So you can say, I want to call clear, I want to call this, I want to call that. And you can really imagine sorting this so you have a file that does like all of your array functions. You have a file that does all of your maybe game manager functions, like certain things you can just bag into one little bag and then export it. So I'm going to leave that there. That is a very basic JSON object. This is also a JSON object, right? Like this is also a bag of stuff. It's got a bunch of different things in it. So if you wanted to console log this, you could. You would do console.log parentheses, and if you type json.stringify and then parentheses, that allows you to put in a JSON object. So if we copy this one here, actually, we should be able to do, we're just going to copy this one here for simplicity's sake. Control C, Control V, semicolon, Shift Alt F to beautify, Control save, and then go ahead and hit run. I missed something somewhere. Oh, it doesn't support export. Let's just comment this out, Control /. There we go. Go ahead and hit run. Hey, there we go. And so you can see that this bag of stuff was able to be logged to the console. If I don't stringify it, it should just be, oh, in this case it supports it because it's basic data values, but when it gets to more complex structures, it doesn't necessarily support it. Yeah. Anyway, there you go. So, like, sure, technically you can do that, but it is a lot better if we define the data value. Okay, so now we're going to talk about types. And we can create our own custom types, which basically are just JSON objects. And so we're going to define a type right here. So we're going to say type student data equals a curly braces, and this is where we define the types for the student data. And so we're saying that there is a grade, which is a string, and we're saying that there is a name, which is also a string, and we're saying that there is a grad year, which is also a number. I was thinking to myself that we haven't talked about some of the other basic variable types. So let's say, I'm just looking for something binary, so we're going to say is currently a student, and this will be a Boolean, so it's true or false. And I'm trying to think if there's any others. So we've talked about strings, numbers, Booleans. I think we've talked about, we've talked about like all the basics, I think. If I'm missing one, I'm sorry. But yeah, Boolean is a true or false. So it's like, is it true, is it false? And you'll see that here in just a moment. So now that we got this student data, we can now create a student data. So here we've got the student data map. We've now defined the type. So instead of saying that the student is mapped to this bag of stuff, we can now say the student is mapped to, and this should be actually capital S, is mapped to student data. There we go. So every student has some student data. Now this is upset because it doesn't have the Boolean. If I type comma is currently a student and then type false, although I am a student of life, you'll see that now it's happy because all of the items are in there, and therefore this qualifies as being of type student data. And like technically that works, you know, like technically that works, but this isn't very pretty, is it? Like why not create a function that says get student data, or rather create student data, because that's what it does, right? Parentheses, and it's going to return a student data, and then we just need to type return, and we can do the same thing, curly braces, and now we can make it really pretty. And I like to just copy this code from here, Control C, and then modify it, Shift Alt F to beautify. And so instead of string, we're going to get their grade, which means we need to actually have a student pass through. So we need student, which is of type student, and we need their grade, which is of type string. And so right here, grade is going to become grade, and then semicolon. The reason, oh, commas, never mind. The reason this works is because this grade on the left is the property, where this grade on the right is the parameter, and TypeScript is intelligent enough to be able to differentiate between those two having the same name. I've heard that it's very confusing to see grade, grade, name, name, but like quite often you'll see that in my code, and as long as it works, it works. So I'm happy. Now for the name, we're going to do the same thing we did before, which is student.name. For the grad year, we do student.grad year. And is currently a student, we haven't added as a parameter, so we can add that as a parameter, which would be is currently a student, which is a Boolean. And then we can set this to is currently a student. We can just pass that parameter in. There we go. Control save. Now that this is done, instead of passing in this data here, we can delete this, and we can use this function. So create student data, parentheses. We need to pass the student, which is Lake's the student. We need to pass the grade, which is A-, and we need to pass the Boolean, which is false. And because it's so well named, when you hover over it, is currently a student, you're like, oh yeah, I know it. I don't need to explain what any of these values are. And that's it. I find that so much easier to read. This function becomes super useful. You never have to type those curly braces again, right? Like this is what being a coder is about. It's about making your life easier. So, that's pretty good. I want to review and make sure that I didn't miss anything that's like blindingly obvious to me, but not obvious, right? So there are a couple things. Let's start with the type. So we have the type named here. The reason we do capitals, this is called Pascal case, where it's both caps, where all the words are capitalized, is because later on, when you create a student data, like you'll see this map is lowercase. The data values are in camel case, where the first word is lowercase. And if we did this, there's another way you can do this, which would be called, you'd say constant Lakes, we'll call this student data. So we'd say constant student data equals create student data. And we're going to pass in this information here, Control C, Control V, semicolon at the end. And we're going to pass in student data. And so here what you're seeing is by making this one camel case, where it starts lowercase, and this one uppercase or Pascal case, you're getting, they're different, right? And you can have both, and that's amazing. So you can use this, and when you see it in camel case, you know, oh yeah, that's what stores the data. This is what defines the data. That's why our classes, which are reusable templates, are capitalized. Our types are capitalized, but everywhere you see variables, they are lowercase to start. So Pascal case is double uppercase, and then camel case is where it starts lowercase. So it's like the humps on a camel. Yeah. Okay. I think that just about covers everything related to that. Oh, well, no, it doesn't. There's always more. So we've got our type. We've defined our type as student data. We've equals a bag of stuff. So the curly braces creates the bag of stuff. And then grade, colon, is then defining the type that the grade is. And then the comma separates the line. Technically, as you saw earlier, you can put this all on one line. Don't. You'll see crazy YouTubers that make their code look like art. Don't do that. This is really hard to read. This is not ideal. Sure, it's 3 less lines of code, but it wasn't worth it. It's all about readability. The size of the file doesn't really change. This is what you want. You want something you can really clearly read and understand. Okay. And also, readability and understandability is a personal opinion. So there are things that I do that some people find harder to read that I find way easier to read. Kind of like what we were talking about earlier with the strings up here, right? Whether you're creating the string this way, oopsie, come on, let's not break anything now. Where are we? Where did I go? I lost it. I don't want to break anything. It should be highlighted. It was, there it is. So whether we're talking about, creating a string this way or creating a string this way, those are personal preferences. And as a coder, you're going to create your own personal preferences. You're going to have those things, and that's great. It's great to make those decisions for yourself. In the beginning, maybe you copy my styling for a while, but eventually when you get to the point where you can make your own choices, feel free to make your own choices. Anyway, I'm just saying. So I had a friend approach me just yesterday asking about his code, and I was like, yeah, sure, you could optimize this, but if it's not broken, you don't need to change it. This is fine. There's many ways to do the same thing. And, I told him how I would do it, so if he ever needs to, he knows kind of why I thought that way and what I would do differently. But I was like, it works, dude. So it's good. So anyway, whew, we are almost done. We are really rolling through these. Just 4 little lines left. Okay. If statements are super duper easy, and we're going to go ahead and say if parentheses Lakes the student dot grad year is greater than 2000. Let's actually do something funny. So we say less than 2014. Yeah, 2015. There we go. Okay, so if Lakes the student dot grad year is less than 2015, console.log parentheses Lakes the student dot name plus space is a boomer, comma, lol. All right, and then run. Boom, Lakes is a boomer, lol. Now let's go ahead and add an else, curly braces, and what you're seeing here is I feel like it's really easy to read, right? If, then we have the condition. So we're taking a number value, saying if it's less than. There are a lot of different conditions you can do. We'll run through those in a second. In this case, we're just using a number. And if we want to do when it's not true, we can reverse this and say greater than or equal to. But in this case, we're going to say else, and we're going to just do Control-C, Control-V. And since this is all about slander, hey Nalia, since this is all about slander, let's go ahead and say Lakes the student dot name is a is Zoomer slander? Is that what they call them? I don't even know. But then what we can do, since when you run this, it still is, because my number hasn't changed, right? We can then change that number by saying Lakes the student dot grad year equals 2016, and then hit run, and boom, now it says Zoomer. I think that's what they call those people. I am not hip enough to know. So that's pretty neat. Now we're going to comment this out, and then we're going to come on down here and create a different type of if. And so we're going to say if, and parentheses, and we say Lakes the student dot, we don't have his grade yet. So let's go ahead and get a grade, right? First of all, we have student data map. So we're going to create a variable. So if we want to get values out of a map, you remember that they might be undefined. So what we would say is constant student data, let's see, Lakes student data equals student data map dot get parentheses Lakes the student. And so now that we have the student data, it could be undefined. So what I often write is if that data is defined, so we say if Lakes student data. Sorry, Nolly, I'm still working. I'll be out in a little bit, okay? So we have Lakes student data equals student data map dot get Lakes the student. We then need to verify that that data exists inside, like that we got valid data. So we say if Lakes student data. Now inside of here, if I make if I type Lakes student data and hover over it, you'll now see that it is defined as student data because it's inside this if statement. Whereas here, it says it could be undefined. Now it's no longer defined. And now we can write another if statement, so a nested if, and we can say if, parentheses, Lakes student data dot grade triple equals a minus, and then we could write something, right? Like we could say, let's see, console.log try harder. Okay, we're just having fun. We're just having some fun. And then we could say else if. And so when you type else if, it allows you to put in another parameter where you could say if Lakes student data dot grade triple equals. And we use triple equals to check, just don't use double equals. It won't log an error, but it could create errors. Double equals was one of the very first equal, it was the very first equal symbol in TypeScript or JavaScript, and it comes with some really crazy things that we're not in a place to talk about. Just forget it exists and always use triple equals. Triple equals is the way to go. If you want me to talk about it in a future video, just ask in the comments and maybe I'll do that. All right, Lakes student data dot grade triple equals a plus. Then we can say console.log parentheses nerd. And then we can do one more else, and then parentheses and curly braces. Oh, there's no parentheses, right? Because it's just an else. My bad. And then in this case, I'm thinking Control-C, Control-V. We move try harder down here into this else because, and we'll just say weak sauce. There we go. Yeah. And there we go. So now we've got these kind of like 3 different logs. Obviously, you could keep else ifing. So you could just keep else ifing and else ifing until you had all the grades. There are games made that way. It's not ideal, but honestly, if you can get something to do what you want it to do by doing that, by all means, go ahead and do it. I'm going to show you a switch statement next, which is a little bit more easy to follow. But there's just better ways to track grades, right? So rather than using a letter system, you might use a number system that correlates to letters, where 0 is like A++, and then 1 is A+, and then 2, and so on. So you could use a number to like say greater than, less than, that sort of thing. But anyway, that's more technical than we're getting into for today. We're just really trying to show a bunch of basic stuff. So we got this if statement, and we should be able to click run, and we get weak sauce. And if we comment out wherever I am, I guess we're just going to leave that in there. That's fine. Yeah, we're going to comment this out. I don't want it constantly calling me a boomer. Control/. So now that we got this set up, we can, of course, change the data. So now that we've verified student data here, we can actually say Lake student data dot grade equals, and then change it to be an A+, and control slash and run. And we got, oh, I have to hit run again. Run, that's so weird. Oh, it's because I commented it out like an idiot. I meant to comment it out after we were done running all the code. There we go. Now we got our nerd, and then if we change this to just be a B, simple B, and then run, we get try harder. So control slash, there you go. So that is some basics with if statements and else's and all that good stuff. Next up, we have switch in case. This is something that I don't use it nearly as much as I used to. They're kind of cool, but I don't know, they're just not as useful as I'd like. So we're gonna just ask for an example. Show me a simple switch case. Okay, let's see if it understands what I meant. Thank you. So it's got Tuesday, and it checks based on these dates. Yeah. And so basically what this switch case allows you to do is you say switch based off of the day, and then if it's case Monday, you can say start of the work week. Case Tuesday, second day of the work week. Case Wednesday, midweek already. And so on. And like, there is definitely a use case. See, like right here, this is a great example. Saturday and Sunday, it's the weekend because these run the same code. Now, in an if statement, we would just say if, it's equals Saturday, or, I guess I haven't shown you an or statement, or Sunday. So we could say, watch this. Okay, yeah, this is great. This is a great example. So in this if statement, we can copy this, Control C, and then grab ampersand, ampersand, Control V. And what this does is it says if the grade is A, oh, I meant or. So ampersand, ampersand is the and symbol, so both of these things would have to be true, which obviously you can't have two grades, that's impossible, hence it's giving us this error. But if I change it to an or statement, which is slash slash, so you remember the slash from earlier for or? Well, two slashes in an if statement is also or, and that will also log nerd. So we'll go ahead and switch this to an A, Control slash and run, and we get nerd. And we can switch that back to a B and run and get try harder, and then Control slash, turn that off, and Control save. Okay. So yeah, that's how you do an or. And with and or, you pretty much have I think all the basics. There is a thing called not that we should look at. There are so many things we could do. So like, watch this. I guess if we say else if parentheses my brain is trying to figure out, like, the logic when you start using not is reversed, right? Because you're saying it's not something. So I'm just going to write one in and say Lake's student data. Yeah, okay, I figured it out. So we'd say if Lake student data dot grade does not equal an F, and then we could say and we'll copy paste this, Control C, does not equal an F minus, and we'll do one more of these. So we're saying for all of the F grades and F plus, if Lake's is not all three of these, so he's not an F, he's not an F minus, and he's not an F plus, then we're going to log try harder. Then we can have an else statement for those F grades, which would then say console.log really? Come on now. There we go. All right, and then we'll go ahead and hit, change this, Control slash, change that to be an F, and hit run, and you get really, really come on now, whereas if we change it back to a B, we get try harder. So there we go. That is some more examples of how you can use, and so this is the not operator. The not operator can be used in a lot of ways. You can use it to flip a Boolean. So if we said let is, we'll call this some Boolean equals false, and then we say some Boolean equals not some Boolean. What this will do, there we go, is it flips it. So by saying not some Boolean, we know that this is false, so not false is true, so some Boolean becomes true. And the same thing happens if this is true, right? So if this is true, some Boolean not true is false, so then it turns it to false. And yeah, so that's how you flip a Boolean, and pretty cool, pretty cool. There we go. Okay, so this switch statement, I mean, this is a good example of it. Like I said, it allows you to do the same thing, so this is kind of similar to an AND. There are definitely places where I've used this. It does allow for a default value where you could say, oh no, that's an invalid day. Like if you type in a string that's not, like an invalid grade would be great to have, right? But it does, I don't know. I just haven't used them recently. I used to use them all the time, but I just have not been going, this has not been my go-to anymore. So yeah, there you go. That's how it's set up. The formatting of this, I almost always ask ChatGPT for an example because I always forget that there's a colon here, there's a parentheses here, there's a curly brace here, there's no colon here. Genuinely, like, this is one of those things where I have to review my own code or look at a basic example to remind myself because I just don't use it very frequently. And that's totally okay. So, okie doke. That covers switches and cases. And now it's time to use async and math.random. And I think we can do this. I think we're going to comment out this code as well. Control slash. Go ahead and hit run. There's no code running anymore. So if I'm not mistaken, let's start with math.random. Console.log math.random. Need parentheses to get the random value. So just like starting to get used to, you always use these parentheses. Then we'll hit run. Then we'll hit run. There it goes. And so here's the value we got, the random value. It's a number between 0 and 1. And so as we randomly sort through these, you'll see there's quite a few values coming up. And, you know, that's cool. So we got math.random, and it allows us to get around between 0 and 1. There's a lot of ways to use this, and I'm going to expand upon them using some math in a minute. But first, I was thinking it would be nice to see these values constantly changing. So what if we did a while loop? And this is something I don't do very often, so I might need to grab an example. And we're going to say while, let's get an iterative value here. Ooh, here's a great idea. We're going to use the time. So we're going to say constant current time equals date.now. What date.now does is it gets the current time since the epoch in milliseconds. And we should just console log that real quick. I'm going to control slash, and then I'm going to go console.log current time. And then let's say while current time is less than date.now. So basically what I just wrote here is once this is over, it stops running. So we'll go ahead and hit run, and we can see we got the current milliseconds. Ignore this. We're really just focusing on current time right now. So we got current time. This is the number of milliseconds that have elapsed since the epoch. Now, the epoch means the moment. It's a universal starting point for computers. You're going to see this pretty much everywhere. And yeah, so that's the value we use to track time. And by having the current time, we can now utilize that. And I think we're just going to Control-C, Control-V, Alt-C, Control-C, Control-V, there we go. Alt-arrow down, Shift-Alt-F. We've got the current time here, Control-C, Control-V, Alt-arrow down, Shift-Alt-F. And then what we can do is rename this one to the start time, right? So this is the start time, and we're going to log the start time so we can see it on the console. We're then going to say while the start time plus some duration, so we want to know how long do we want to run for. So we'll say constant run for in milliseconds equals, we'll do 2 seconds, so 2_000. There are 1,000 milliseconds in 1 second, so this is 2 seconds. And then we can say start time plus the run for milliseconds. And while that is greater than, oh my gosh, I had this backwards. I hope I didn't break anything. It doesn't appear to be. While start time plus run for milliseconds is greater than date.now, because it's greater than for a minute, then once after 2 seconds, we're done. Now I'm going to run this, and this shouldn't break. While loops are pretty solid. They can do quite a bit before they break. But eventually we need to add an async delay in. So we're just going to start with no async. And so we're going to constant current time is going to be set to date.now, and then we're going to log the current time. And if we hit run, there we go. So this got backed up because it did too many things. But here you can see every millisecond elapsing and from the start. So we started at 646. I'm just reading the last 3. And we ended at 64. Oh, right. We need to read the last 4. So it started at 2646 because this is the seconds value right here, 2. So this was 2, so it should go to 4. And right here we can see it's at 4. There we go. Very nice. So it ran for 2 seconds. And now what we want to do is await. And I genuinely don't do this very often, so I want to say copy and then say, can you add an await or delay to my while loop so it only runs once per 100 milliseconds. There we go. All right. Yep, we use await just like I thought. And I don't like the way that it's doing this. We're going to do it differently. Yeah, we're going to do this differently. So let's see. We just type await new promise, if I'm not mistaken, and then set timeout. Yeah, so while loops are different. In Horizon, we have just some different ways of doing it, but I'll try to show you that in a second. Say await new promise, and so we've got new promise, and then I just don't use promises very often, so this is like more or less if you want to do a while loop with a delay in it, you kind of just got to memorize this or have a copy that you can come and look at. And so we're going to do parentheses resolve and then arrow function, and let's just keep copying. Set timeout. So we should have a set timeout available to us. In Horizon, it's available via async.setTimeout, and it's only available from inside of, well, anyway, we'll get there. That's way too advanced. We're not going to talk about that. Okay, so await new promise, resolve, arrow function, set timeout, and then parentheses, resolve, and then comma, and the milliseconds is 100 milliseconds, and that I thought would work. Why is it not happy? Await expresses are only around the top level of the file. What did I do wrong? Wait, sleep. Okay, so I'm thinking it's just not supported in this playground, which is totally okay. It says that this isn't a module. It doesn't have any imports or exports. That is a feature we definitely have in Horizon that it doesn't seem to have here, because remember we tried export earlier and it didn't work. So, but what this would have done is it would have delayed this and it would have waited for 100 milliseconds and then run the next loop. So that's kind of cool. So I did want to see, do we even have set timeout in here? Let's we'll control/ this here and see if I type set timeout parentheses and set timeout async.set timeout parentheses. It has an arrow function, and then curly braces is the code we run, and then comma 100 milliseconds and semicolon, enter, and then we just need to console.log the current time. So we'll just do these two things, Control-C, Control-V, Control/. So we say constant current time equals date.now, constant console.log current time. We could just replace this to make it cleaner, Control-C, Control-V, and delete this line. So after this 100 millisecond delay, we're going to do an additional log. So let's go ahead and hit run. Oh yeah, that totally worked. Nice. For the sake of this, is there a way to make this work? I'm trying to think. Can we use set timeout to create what I'm looking for? Like, if you watch it, you'll see it kind of flickers as the 2 there. If I change it to 1,000 and hit run, you'll see it actually takes 1 second, and then the next one appears. So it goes 1. There it goes. So that's pretty cool. Is there a way to get this to work? Is there a way to get this to work with the way that we have this set up? There might be. I guess I'll show you one additional async feature that's really awesome, which is set interval. And yeah, that's going to do what we want it to do. So I'm going to go ahead and comment this one out, Control/. I'm going to copy this code, of course, Control-C. So set interval is the same thing, and I do need to break this down a little bit and explain more of what's happening inside of it. But let's go ahead and do once every 500 milliseconds, and we're going to paste this here, and then what we can do is when set interval goes off, you'll see it returns a ID. This number is the async ID, so we can say constant async ID equals set interval. And then what we can do is copy this set timeout. In fact, we're just going to move it down and Control/. And this is what's going to clear the timeout. And so we can say async ID, we call clear interval, parentheses, passing in the async ID as a parameter. And that's going to stop this interval from running. And then we'll do that after, let's say, 5 seconds. Okay, so now we hit run, and now for 5 seconds, 1, 2, 3, 4, and 5, it's run. So there's now 10 logs roughly, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, beginning and ending, right? And that's amazing, right? So we've now created something that has a delay in it, and that's pretty fantastic. So I was talking about this at the very beginning, this idea that when does the thing happen is very important for, like, how do you develop something that actually causes something. I have a pause feature on my recording, and I think I'm going to hit it, grab a quick bite, just revitalize my juice, and I'd like to start showing you more of this concept of when a user causes action, and then there's a reaction. I think that's really important. This is very long, so I'm fatiguing. You're probably fatiguing. Do feel free to split this across multiple days. If you're doing really well, and this is like maybe you're relearning concepts you already understand, feel free to keep going. But I'm expending all of my brain juice because this is a lot. It's and I'm trying to cover all the basics. I wrote down as many basics as I could think of, and I think no, we've done one. We've done one line of this idea of things I wanted to cover in this video. That's just so hysterical, but that's okay because we've covered so much great stuff, and that was the point of that one line. So let me make sure we've covered all the things here, and oh, right, I was going to explain async. So let's talk about this just a little bit further. Okay. So you've already learned how a function can return a value. And I mentioned how that's going to be seen a lot. This is one of those examples, right? It's returning a number. It doesn't explain it, of course, but that number is the ID that you use to cancel or clear this interval. And so we save it. Then we have the set interval. That is going to create a looping function that goes off on an interval. It doesn't run until half a second later. So it waits 500 milliseconds before it runs, and then it starts running. This is an arrow function. It's where you have parentheses that could have a parameter in it, then arrows to the right to curly braces where we call the function. You're going to remember seeing this all over the place, especially up here when we were doing the for each. So we should have a for each in here somewhere, right? That's where I use it most of the time. Man, this is a lot of code. Here it is. So here's our for each, which is similar. It's another arrow function, right? You've got your parameters and then an arrow to the right, curly braces. So we're familiar with this. This is stuff we've gone over. And I'm saying that to help you ideally feel comfortable and be like, oh, wait, this isn't that scary. This is something I've seen before. And so then inside of those curly braces, this is the code we're running. So we're running console.log. Now, typically, I would call a function because there's going to be a lot of code being written. I do not recommend writing a lot of code inside of one of these curly braces. This should be calling some other function, so that way it's just one line of code. Because then at the very end, you can see how long is it waiting, 500 milliseconds or half a second. So keeping this short and concise, I find, is really important. Now, set timeout does something very similar to set interval. You see the same arrow function, same curly braces, same delay, but it only runs one time. So there's no need to like save the number. Obviously, there is a number. You could cancel it. So if it's a very long delay, you could cancel and clear that timeout before it happens. So they're like, yeah, same things. Okay. That seems to cover the async and when does the thing happen. Now, I feel like we've covered math.random. I feel like there's more I wanted to say about it though. So let's quickly do some math.random stuff. So what I want to do first is say constant math, I really need to go get that bite of food. We're going to call this random number, and this is going to be math.random. All right, and then we'll just console.log the random number. Simple. Okay, now that we've done that, we now need to talk about different types of random numbers, right? So I'm going to comment out this code here so it doesn't run anymore, and then hit run, so it's just showing this random number. We're also going to comment out this one. There we go. All right, so here we have the random number between 0 and 1. Now, what if we want a random integer? And if words like integer scare you, it's okay, they're not scary. It just means a whole number. So it's 0, 1, 2, etc. And we can do that by typing math.floor and parentheses math.random. What math.floor does, we have to use an equal symbol. I need parentheses there. There we go. What math.floor does is it removes the decimal places. So if I hit run, we gotta console log that, Control C, Control V, Alt arrow down, change to random integer, Control C, Control V. And by the way, this is a double click. Triple click selects the whole line. Double click selects the value. Very useful. We'll go ahead and hit run, and now you've got 0, because if it's a random number between 0 and 1, it never actually is 1. It's like 0.9999999 at best. And so this random integer will always be 0. So there is another way you could use ceiling. So if you want to round upwards, you use math.ceiling. So we can hit run. Now it's 1. But you could also, and I recommend using floor just for reference, you could also get the closest value. So to do that, you take math.random plus 0.5 and hit run, and now it's going to be 0 or 1. And what we should do is use our random number to select the random integer rather than using math.random, so we can see how those two numbers correlate. So we'll type random number in here, and now we'll hit run. And so here we have 0.31. You add 0.5 to that, and you get 0.8. We run again, and we run until we get 1. There we go. 0.9 plus 0.5 is above 1, and therefore, when you use math.floor, it rounds to 1. And if we do that again, here's 0.5. 0.5 plus 0.5 equals 1, so therefore it's 1. And so that's how this, random integer works. Now, this is just a value of 0 or 1. If we need the value to be, a random constant, random int, random, I want to say 1,000, like up to 1,000, but I don't want to use a number. Random large int. We'll just use that. And so a random large int is going to be taking our random number, multiplying it by 1,000, and then we'll put parentheses around it. So remember, highlight and then shift opening parenthesis, or shift 9, and then math.floor, and then a semicolon, and hit run. Or we need a console log here still. Console.log, parentheses, random large int, and control save and run. And here you can see I did something wrong. Random large int, math.floor, random. Oh, I did random integer. I meant to do random number. Control C, control V, there we go, and run. And now you can see that it just moves 3 of the decimal places over. So 596 gets moved to the left. And we can run that a few times and you can see that. Now, with that set up, it's pretty nice. These numbers for this one will always be between 0 and 999. It will never be 1,000, because just like we said before, this math.random is 0 to 1, but it's never 1. So now that we've got this random large int set up, you might not want it to be an integer, but we're just going to talk about integers for now, because that tends to be the case. What if we want a large number of random numbers? So we might want to make a bag of numbers or an array of numbers. We'd say constant large array, large number array, and that will be of type number array, which will equal an array. Now, something interesting here is this is an empty array. Technically, you can fill it with default values like 0, 1, 2, 3. And what I actually end up doing with this website in particular is coming here to generate random integers like this in a large array, and then I copy those values and paste them into my Horizon scripts. And so I'm just going to show you a little bit of something that I've done a few times. And so we've got large number array created, and then we say while parentheses large number array dot length gives us the length of that array. So it starts at 0 because there's no items on the list. And we say while that is less than 1,000, so that way this runs all the way to 1,000. Remember that underscore is optional. And then curly braces. We can then add a random large integer to the array. And to do that, we'd say large number array dot push. Remember, push is how we add to an array. And then parentheses. And we would say math dot floor, parentheses, math dot random, parentheses, multiplied by outside of those parentheses. So math.random multiplied by 1,000. And now that's going to give us 1,000 numbers. And I can do console.log parentheses large number array. And what I can then do with this large number array is actually, and we're just going to comment this section out since we're done with it, Control/. What I can do with this array is copy and paste the values into Horizon and use it for whatever I need random numbers for. And so these pseudo-random numbers allow me to create, say I was building a tower defense game and I wanted to make sure I was building random waves, but the waves were always the same. And this 1,000 numbers could create 1,000 different waves that were all random, but also when you play it the second time, it's still the same wave. And then you could copy these numbers, you could have 1,000,000 numbers if you did that 1,000 times. I think you could literally type in 1,000,000 and it would just work. Like do. So if you really need 1,000,000 numbers, boom, it did it instantaneously. There's 1,000,000 numbers. Is that really 1,000,000? That felt kind of small. Oh. I think it might still be running. Oh, I'm not sure because I can't click over here. 1,000,000 might have been a bit too many. Okay, there it goes. That is 1,000,000 right there. Holy moly. I can't even see it because it's so big. Maybe don't do 1,000,000. Maybe do like, 10,000 or something. Something reasonable. Oh my gosh. I've totally broken it. Anyway, just because you can do something doesn't mean you should, as they say. So we'll change that to 10,000, save, and maybe that'll fix this. Oh my goodness. You know, 1,000,000 doesn't seem like that much. And then you see it breaks the computer. Anyway, so here's 10,000 random numbers from 0 to 1,000. And you could easily imagine using those numbers to create some sort of round or something in your game that feels random, but when they come back and play it the second time, it's the same sort of thing, so you can learn. Anyway, there's lots of uses for pseudo-random. Okay. There we go. Console.log large number array. We did it. Now, technically, you can write this type of code in Horizon and copy paste the numbers. It's just harder to do there because all your code has to be attached to an object, or what we call entities these days. So you have to attach your script to an entity. Whereas right here, I can just run this code. Like, look, that wasn't very hard. But there's another instance here where you might not want to have pseudo-random numbers. You might want to have an ordered list of numbers. So let's do 1,000 again. And instead of adding the number, this random number, let's just add the number that is the length. So we say large number array dot length. And if you wanted to include 1,000, why not? Less than or equal to. We're not going to. I think that might cause an issue with the next step. Anyway, we're going to hit run. And so now we have an ordered list from 0 through 999, and there they are. And the reason we might want to do this is what if we need to include every single value? We don't want to miss one. When using math.random, you're going to have duplicates, which means you don't have necessarily every value. With this, we know we have every value, and so now we need to randomize it. And I genuinely can't remember it. Waffle just taught this to me the other day, and I can't remember. I have a vague idea, but I couldn't find it, so I think ChatGPT is going to be the fastest way to ask. The way that I've done it in the past wasn't the best way, so I'm just going to say, how can I randomly swap these around? That's what I remember it being like, is it was like you're swapping values. Shuffle, yeah, it's a shuffle, okay. Yeah, it's this, and this is the reason I can't remember it, because it's mildly hard to follow. The Fisher-Yates shuffle. I think we added this to one of our utilities, if I'm not mistaken. Let's see if I can find it on my computer. Let's just open up a folder, head over to downloads, array function. Operator function. It could be an operator function. Let's see. Get random numbers from range. Oh no, it would have been in the array function because it's an array function. Of course it is. Duh. Silly me. And it would have a little comment at the top that says thank you to Waffle, but this must be an outdated array function, so I should have downloaded the one from earlier. Let's go to Drive, go to TypeScript Utilities, go to Array Function, download, and that should, there we go. Okie dokie. Minimize. Well, hello there. Array function. And here we are. Oh, this also doesn't have it. Where the heck is that code? I could swear I had sent it. I guess I hadn't given it out publicly yet somehow. Even though I thought I had. It could be somewhere else. In one of these, there might be an array function in one of the other folders. And in that case, I need to update this one real quick. Let's see, where else would we have used it? I think I can just search for util array. Where's search button? Search and drive for util array. Really be nice if February 2nd. 2024. This February 2nd is probably the one, right? That would make sense. Download. It would be really nice if you could preview these on Drive, because that would be really nice. It really would. Here it is. There it is. Shuffle array. Here we go. So if you download this utility file, which I'm going to quickly upload to replace the old one, because this is the one that I meant to share. Let's find downloads. This is the correct one. These two are outdated. Right click, delete, and rename. There we go. And then drag that to replace this one. All right, so replace existing file. There we go. Version number 4 has been uploaded. Let's go download it just to make sure it updated correctly. There we go, and save, open, double click. Hey, that looks good. Okay, we're good. So, opening the original. What we're seeing here is shuffle array in place changes the current array. Whereas, shuffle array returns a new array. Got it. Whereas shuffle array in place is a, yeah, that makes sense. So, I wish I could explain it. I really want to be able to explain it, but it really is kind of one of those things that's very hard to explain. So I'm going to copy this. We're going to use it. You can download the utility and just use that utility rather than having to write it yourself. I think it's exactly the same as this. Yeah, it is. So we'll go with the one that I wrote with Waffle. And so we've created this this loop of code that's 0 to 999. And now we want to go through it and swap them so that the whole thing gets randomly swapped. So we've got let I equal large number array dot length, and we can swap everywhere that says array with large number array. Okay. And then we've got -1. This part's important because it's got to go less than the limit, right? Makes sense. And then I is greater than 0. So while I is greater than 0. This seems like a catch, just to make sure, I assume is what this is. And then we say I minus minus. Does ChatGPT have that in there? It does. Very curious. This, like I said, I can't fully explain it. Oh, it's minus. Oh, it's minus minus. Okay, so you see what's happening here? It's starting at the top of the array. Sorry if you can hear the sirens in the background. But it's starting at 999, and then it's going backwards, so it stops at 0. How interesting, how peculiar. There's a reason for this that I don't really understand, because I did it the reverse where I started at 0, and that was the problem with my code, is I started at 0 and swapped them. Really confusing why that makes a difference. I wish I could remember what Waffle said, because he explained it very well, and then, you know, life gets in the way of memory. So constant j equals math.floor, so we're getting a random value, math.random, and then we're multiplying that by I plus 1. Why? What's happening here? You know what? I'm not even going to try to explain it. I'm going to get so lost. It's tough. Okay, so we start at 999, right? And then that goes into this value slot and this value slot. So they're being swapped. So you see this array here is going to be set to be the swap of it, where you swap those two values. So it's like ij, ji. That's what we're doing. We're swapping these. And like this is just something you'll have to memorize. There's not like a ton of logic behind it. Like if you need to do a swap, that's what a swap looks like. But what I'm trying to wrap my brain around is this math that's happening here. So I starts at 999, and then it goes 998, 997, and so on. And then j is a random number, math.floor, math.random, multiplied by I plus 1. Why are we multiplying by I plus 1? Interesting, interesting, interesting. It's trying to make it so that we don't swap values that have already been swapped, if I'm not mistaken. So I plus, because somehow that shifts the weights of the whole array to be more, if I'm not mistaken, more lower values are at the bottom half than the top half. And so by keeping the random value we're getting to be one less than what we've already, where we're at, we never swap twice somehow. Somehow that makes it work. I don't understand entirely. As much as I love math, and I kind of have a vague understanding of this, it still is kind of like, wow, what a mystery. Math.random times I plus 1. So it starts at 1,000, then this goes down to 999. And so it's only swapping values between itself. Interesting. So if we're looking at this value, right, like 999 is going to choose one random value from the rest of the set, and then that is the random value. And then 998 is going to do the same thing, so it's choosing a random value from the rest of the set, but it cannot select 999. And I think it starts to make sense when you like see that, because this value is no longer a high value. So if it's selected the value that's lower, so it shifts the values to be lower on the left and higher on the right. Right? Or is it lower on the right? Or anyway, as you can see, that if you don't randomly select, it's going to have an opportunity to select, I guess. Oh man, it's so confusing. But if you do it inaccurately, it's still close enough. Like we're talking about just small percentage points of being slightly off. But anyway, it's better to just do it right. Okay, not enough tangenting here. I'm so sorry that went off. I just really did want to wrap my brain around it. And so now we're going to hit run. And there you go. There's a random swapped, perfectly random array that you could then copy that has every number in it, which is fantastic. Like, look at, there's 0, and so on. And I guess this would probably work if we wanted it to go to 1,000. Like if I said less than or equal to 1,000 and hit run, it has no problem with that. So hit run. There you go. And so now we've got a new array, and the number 1,000 should be in there somewhere. I'm expecting it to like stick out a little bit, because 3 zeros, and will I be able to see it? I'm not sure. So many numbers. But yeah, that should have worked. I should have console logged the position of 1,000 to find it. My eyes are just like, is it there? Is it there? Okay, here we go. One more. We do console.log the large number array dot index of parentheses 1000 and run. Try that again. There we go. So 390. It's at index 390. So we go to halfway and then look up just a little bit. Should be right in here somewhere. Right in here somewhere. There it is. 1000. Okay, we found it. Cool. So now we've got numbers from 0 to 1000, right? Like that's pretty sick. That was a long way to prove that there's 1000 in there. But yeah, very, very cool. Yeah, I think that's where we're going to end with this whole playground. So I'll be able to share that in the description. So if you want to open this up and look through this code and play with it yourself and make some changes, you are welcome to do that. I do encourage you to write it all out yourself as well. So like watching the video and writing it, I think is the best way to learn. You get that muscle memory as well. Yeah, so we're done with that. I've got this URL to remember to copy, this URL to remember to copy. And I'm going to go do my food energy break, and I'll be back to keep this going. We're gonna in this next half. I'm really excited. I hope it's not another 3 hours. I'm hoping it's like an hour, 2 hours tops. But I also know that this is probably one of the most valuable tutorials I've ever made. So I'm hoping it's helping. Please let me know in the comments if you're enjoying this. If there's other topics, of interest or something like that, or things you'd like us to go deeper in. Let me know. But in this next half, we're going to start by creating an empty world in Horizon. We're going to think about action and reaction. I gave a talk that I'd encourage you to check out. There's a link in a video somewhere. It's what makes a world go viral. There's a video on our channel that links to the proper video for that because it's a Meta-owned video. They own it, so I can't just share it. But that talk talks a lot about how creating action, when the user creates action, it creates this kind of excitement and enjoyment, and that's what really makes things fun. So that's what we're going to talk about, is just creating action and how do we create action, all the different ways we can create action, because what we've talked about so far is just like coding principles, but now we need to take that and apply it to something. And we won't use a lot of the advanced stuff. We're just going to look at really basic examples like player enters trigger, poof of smoke, or whatever. We're going to do like a teleport. That's a classic. So you enter, player teleports. We'll have something like when they grab something, something happens. And just various things like that to really get you started in thinking about Horizon and how that actually works. So yeah, without further ado, I will BRB. Rice. Oh, this is my lunch. Already feeling so much better. I was really debating whether to split this video into 2 videos, but I think one really long video makes the most sense. This next topic definitely could be its own video, but I think the precursory knowledge that we just got is so valuable. So what I'm going to do instead is afterwards I'm actually going to put chapters in. So I'm putting on my to-do list, add chapters. So that'll be fun. Alrighty, I'm going to pause and eat, and I'll be right back. Alright, we are back. There was something I wanted to say, and I think I've lost it. So, oh yes, here it is. We are going to be using Horizon to create this action and reaction. TypeScript is a pretty large language, so some of you who might have joined us so far might not know anything about Horizon. In that case, we do have a tutorial released a few weeks ago, about maybe just 2 weeks ago, on how to install the Horizon application. More or less, you need a Meta OS, you need a Meta account. I believe you might need to apply to the MHCP. I'm not entirely sure. I might have to look into that. I thought it was open to the public now. I think the MHCP is something you apply to if you want to make money. So as long as you're just here to create, I don't think you need to worry about that. But if you want to make money, apply to the MHCP. I think they're letting people, like everyone in. I don't think that's they want more people, so I don't think that's a problem. Just know that the money does ruin the fun element of it. Like it does impede your ability to enjoy it. So anyway, you're going to need to have a Meta account. You'll log in, then you have the application. There's a new desktop application. So if you watch some of our older getting started videos, we used a completely different application. We're now using the standalone desktop. It's so much better. Really love it. You don't have to deal with any of the other hiccups. So you'll see that in just a moment. If you're installing that, you need to install VS Code and then restart your computer. Again, there's a video. It's like 15 minutes long, but that's basically it. You install VS Code, restart your computer, then you install the Horizon Desktop Editor. You would log in with your Meta account. That's more or less it. Today, I wasn't planning to do too much like basics on how to use the editor. I might need to. So I'm going to try to say out loud as I'm doing things. So as I'm clicking like WASD to fly around, am I clicking the right click button to look? Stuff like that. I'll try to say it out loud so you can kind of coordinate if you've never used the desktop editor before. Okay, I think that is enough jib jab, which is apparently a thing I say. I don't know where it came from, but it's hysterical. Let's go and dive into Horizon. So the new desktop editor is not this one. Let's see. I think I found it. I had it saved on my hotbar. Should appear any second. There we go. Excuse me. Let's go and make sure that fits in the space. Right about there. Looks good. Perfect. Alrighty. And want a new world. So yeah, you'll install this, you'll log in, and then you'll be on that screen more or less. We're going to create a new world just so that we have something blank to work from. And any moment now. Man, I was watching back some of that old getting started on the desktop editor. It's not great. A lot has changed. Like I said something to the effect of you can use the you can use primitives. You really can't use primitives anymore. It's not okay, and code blocks is not recommended anymore. It's kind of gotten crazy. Yeah, so welcome in to the desktop editor. I like to close out of the Gen AI tab. There are some cool things in here. I mean, come on, generate a skybox. Let's see, stars and giant planet with rings around it, massive golden desert landscape. I mean, these are so fun. Man, this is totally going to impede it, but I think this might be one of the coolest things that they actually have is building a sky dome. I wonder how long it takes to create. I'm not sure if I feel like I've done this before. I'm pretty sure we did this. But anyway, there's a lot of AI features. Meta's big on AI. They've got their llama models. If you're not familiar, those are some of the best in the industry. And I don't say that because I'm a huge Meta supporter. I say that because they are actually pretty insane. And the fact that they've been open sourcing them sort of has been pretty awesome. So anyway, AI tools, they're getting developed. They're a love-hate relationship, but I'm about to sneeze. All right, that is finished generating. I was able to pause so you didn't have to hear me sneeze. I see 3 dots, saved asset library. It's weird that it has this save and apply button, but it doesn't appear to be there. I wonder if it's like you have to have a gizmo out or something. Let's see, my assets. This might be my first sky dome that I've built. I'm not entirely sure. Gen AI assets. That's not it. My assets. Where did it save? Oh, there it is. Pull that out. I'm expecting it to be exactly that. Oh, that's beautiful. All right, let's see how it looks when we go into preview mode. Wow, that is so cool. It's not perfect. I mean, that's a lot of errors off there on the horizon line. I would definitely, cover that up with mountains and stuff, but the sky's really pretty for just kind of like off the cuff, very low instructions. Wow. Yeah, so anyway, I guess we'll have that in our world while we're here. And you can create sound. Sound is really the one that I've used the most, sound effects, because you can create some really custom sound effects. They are typically pretty, how do you say, horrific? Like, it's AI, so it doesn't really get it yet, and so they come out uncanny. Yeah, so it's great for horror worlds. Textures are also really grungy, not very good, and the 3D models I find are okay, but the textures that come with them are pretty bad, so you kind of wind up in a weird situation there. So anyway, we're not going to touch any of that. So we're closing out of the AI tab. I like to move everything that I'm not using to 0, 0, 0. That's just where I hide stuff. That's also where our world spawn point is. So yeah, okay, welcome in. Welcome into the builder. I'm like, oh man, there's way too many things here, so we gotta be careful. I am way too easily distracted. So right now, I am right-clicking with my mouse, and I'm using my WASD keys to fly around. So left, right, forward, back. You can also use Q and E to go up and down, or that was down and up, so Q is down, E is up, and so on. So yeah, that's movement. Now, what we want to do next is we want to cause some sort of, action. That's what I keep talking about. And we're here to learn scripting, so let's go ahead and do it. We go up to our scripts tab. We're going to go ahead and create a new script. This one is going to be called, let's see. Let's call it bounce. Bounce, and naming a script is really important. Everything about naming is important. If your code isn't readable, if your scripts aren't readable, you're going to be in trouble. So this is a bounce trigger. So it's a bounce trigger. And I personally use these like post fixes to provide more detail. And this gets attached to an entity. So I say it's an entity. And then if you're coming from code blocks, which is the previous coding environment in Horizon, we, in addition to calling objects entities now, and we do that because, as you learned just in the beginning, an object has a completely different meaning. Those are referring to JSON objects in TypeScript, which is why we use the word entity, because otherwise there would be a naming convention collapse. I meant contradiction. But anyway, there are also scripts. So in code blocks, we had to attach scripts to entities, but in TypeScript, we don't have to. We can have data files. And so in those cases, I use like underscore data, and you can have function files, in that case, underscore func. And yeah, so very cool. Now that we got this bounce trigger script though, let's pull out a trigger to attach it to. So we go build gizmos, and we're gonna find the trigger. We're gonna just drag that out into our scene. And now that we've got that out, I'm gonna move it to a position that makes sense. So let's go to 2, maybe 0, and then move this down to 0. There we go. And then let's go to like 4. And now that we have that in place, we can change the scale of it to be like 0, like 0.1. So it's just a like bounce pad, which could move that up by 0.5. Oh, excuse me, 0.05. So it's just sitting on top of the ground. And then the other thing that we could do is make it visually indicated by going build shapes, and they have a 10 by 10 plane, which if we pull out, we can move to the same position as the trigger, and we can scale it to be 0.1. Actually, I think 0.2 would look good. 0.2, 0.2, and then select the trigger. You can also click it from over here. Right-click position, press copy position, click on the plane, right-click, paste position. Now that's placed in position. We can then maybe change this to be like 0.18, 0.18. Nice. I like that a little bit better. You can change the color from here too, so we can get a fun color. Kind of got a cool space vibe going here, so we'll do that. And then you'll need to change the tint strength to tell it how much you want to tint. Like 0.5 would be 50% tinted. In this case, I'm going to go to 0.95, so it's almost 100%. And you can also change the texture of this. There is that AI tool to change the texture. Our positioning is a little bit high, so I'm going to move this down to 0.01, so it's a little bit closer to the ground. And the trigger is actually a little bit too small, so we're going to make it a little bit bigger, going to 2, maybe 1.75, maybe 1.65, that's better, and 1.65, nice. So now we've got this kind of like bounce pad set up. We can see that it's triggering players. It is turned on. We can attach the script bounce trigger. So now that that's attached, and then we can select both of these things and right click and write group. Create parent object is the new grouping feature. So create parent object. And then that allows us to move it around as a group, but it also allows us to name it, and we can now call this a bounce pad, right? There we go. And so now that we have this bounce pad, we've got the trigger set up here. In fact, I would go as far as to say that this script should be renamed. In fact, I'm just going to just delete it because we don't need to run on the trigger. I'm going to set this up just what I think is proper. Like I'm going to show you a proper way of doing it, in my opinion, which is to attach the script to the outside, the parent object, bounce pad. So instead, we'll name this script bounce pad because it's attached to the bounce pad underscore entity. There we go. Give that a second. Bounce pad entity. Perfect. And then we can go down here to our bounce pad and press attach script bounce pad. Fantastic. Now, to make a player bounce requires us to turn on player motion. So we're going to need to go to the main menu drop down, go to player settings, and make sure to turn on custom player movement. And we'll press save. That is all we're going to do with that tab for now. There's obviously a lot more in that tab, but we just want to turn on custom player movement. And so now that we have this enabled, we can now go to the script. So 3 dots, open an external editor. This is going to open up VS Code. And in VS Code, we're going to see some things that we recognize and some things we don't. I do encourage you to press yes, I trust authors and allow. Otherwise, you're going to get some really crazy, hard to change things. Just don't do it. Make sure to hit those buttons. Okay, so we haven't talked about imports before, but the Horizon core is the API that is Horizon. This is what allows us to engage with Horizon itself. So that's what this import line does, is it's bringing in the Horizon API. You remember class, and I mentioned we're going to be using a lot of classes, but we're not going to be creating classes. And so the class is that, okay, that's not entirely true, as I'm about to say. We're actually technically creating a class here. And this is because, oh man, but we don't use the class. You remember how we had to write new class? We don't do that. That is not a thing that we do. That is a thing that Horizon does with this class. And so in here, we have this bounce pad. And if I duplicate it, Control D, and slide it over, we'll just put it right about there. Change that to be 3, and that should, oh, -3. -3, there we go. Nice and centered. Now we have a secondary bounce pad, which is also running bounce pad entity. So each of these is running a script. And because they're each running a script, that's why we have a class, because a class can then be applied to each of those bounce pads. And so we have named this class bounce pad entity. It is extending, meaning it is getting the properties of another pre-existing class, which is the Horizon component class. So component is a class. And this special bit here allows us to have a properties panel, and it's a little bit of magic. Just don't worry about it. This stuff, like you can see, is already pre-written for you anyway, so it's not stuff you have to really worry about. So we've got a class named BouncePad entity that we can attach to entities in Horizon. We have a properties panel right here. So the statics props definition is creating a bag of stuff, right? Remember the bag of stuff? So that allows us to create properties for the properties panel, which we'll use in just a moment. We have a start method. This start method allows us to, we receive start from component, from Horizon. And when start is received, that's when the world has started. And that's when we can like start doing stuff. So remember, we were thinking about when does the thing happen? In this case, we have a start. And then here at the bottom, we are registering our entity so that it can be attached to an entity via the Horizon desktop editor. And that's how that works. So, okay, with that said, we're now going to adjust this script to match the way that I like to code. And I don't like the star as HZ. It puts these HZ dots everywhere, and I just don't like it, so I delete it. And then I go and delete all the HZ dots. And then on component, I believe it's control period, allows us to add imports from Horizon core. So you see that right here. And I just click enter, so control period and then enter, and that's going to explicitly import component from the Horizon core. And this removes all those HZ dots. It's nice. I recommend it. Again, there is no right or wrong way there. Okay, so now static props definition is where we define properties on our properties panel. Now this is the bounce pad. We need to know about the trigger that the player could enter. When the player enters the trigger, we're going to bounce them. So here in the curly braces, we click enter, and we need to define the trigger. So we'll type in trigger. And this is another one of those things where you just got to kind of memorize. It took me several months, maybe 2 or 3 months to memorize this. So it goes trigger colon curly braces type colon prop types dot entity and comma at the end. This formatting is a Horizon formatting to be able to define your trigger. Prop types is a list, if you hover over it, of all the options you have, all the different properties you have that you can put on the properties panel. If I hit Control Save now, and we head back into Horizon, and we click on the first bounce pad, and we wait for it to compile. Remember I mentioned earlier it's going to take a few seconds. There we go. So now we can see there's a trigger property on the properties panel. We can then reference that trigger by dragging and dropping there, or if we select the other one, you'll notice that there's actually a search button here, and you could actually search for the trigger, which, I mean, you could do. That should be the right one, but because we don't want to have to rename every trigger, it's better to just drag and drop, or give them really good names in the case that you are building something more unique. We're going to delete this one, but we can just duplicate them later to have more, which is pretty cool. Okay, so this one's been set up. We've referenced the trigger, and now we want to say when trigger is entered by player, send the player upwards. This isn't that difficult, but there are a few steps. So the first thing we need to do is we need to know when the player has entered the trigger. So we create a local method called player enter trigger, parentheses. This receives the parameter, which is the player. So we have player colon, and that player is of type player, which is a Horizon type. We'll go ahead and click enter, and then curly braces creates the method. Now, this player enter trigger is a custom method, so currently there's nothing calling it. So to get this thing to happen, to make something happen here, we need to connect it to that trigger. To do that, we use what's called pre-start. And I'm going to just auto-complete that by clicking enter. Pre-start is another method like start that comes from Horizon's API. So they will call pre-start before the world starts or as the world is starting. And it is guaranteed to happen before all entity start methods, which gives us quite a few opportunities. The most important of which is that we want to connect our trigger to this player enter trigger. We basically do all event connection inside of pre-start. Now, I want to mention this void here before I delete it. Void is saying that this doesn't have a return. I'm just deleting it because you don't have to show it, and I prefer it to not be shown because I find it is a little more than I'd like to see on my screen. I want my code looking cleaner. So there we go. So like start is also technically void, but it just looks cleaner like this. Okay. So now pre-start, like I said, this is where we're going to connect the trigger to this player enter trigger method. To do that, we use connect code block event. And what this allows us to do is connect, this is almost illegible, it allows us to connect a specific thing, a specific type of event. Events are things that can happen. So like trigger entered by player, trigger exited by player, player enters world, player exits world, player grabs object, player ungrabs object, player presses button on their controller, stuff like that. Lots of different events. So we're going to start with a really basic one though. And the event needs to come from somewhere. And in this case, it's coming from this trigger on the properties panel. To reference the properties panel in Horizon, we type props. And if you press enter, that will autocomplete to be this dot props. So that's referring to this properties panel up here. And so this dot props dot trigger is going to give us this trigger here. Now the problem is that this is a property on the properties panel, and if the player doesn't fill it out, or you don't fill it out since you're the creator, right? I make a lot of tools, so I'm like, the creator I'm giving this to. No. If this isn't filled out by you, the creator who's making it, it's going to have a problem, right? Like, because there's nothing to connect to. And so what we need to do is address that a little bit later when that turns red. Okay. So the next thing we need, and you can, oh, Control Z. And you can see that right here. It says, okay, we need an entity or a player, and now we need an event. And to get all of the code block events, you type code block events with an S, so arrow down and then click enter. And then pressing period creates a drop-down list for all the event options. So here's all the items that you can use. And we're looking for the one specifically related to trigger. So I'll type trigger. And we can see index trigger, which is like on your player's controller for VR. And here we've got player enter trigger, which is the one that we wanted. Now we're going to do another comma. And this is where we're going to put in an arrow function. So we do parentheses, and there's a player parameter here. So this is where the player comes from. And then we draw an arrow to the right, curly braces. This is very similar to what we do in our for loops. The big difference for me is I personally really like to have my arrow function just on a single line. I just like it. I think it's cleaner. It doesn't need to be split up because it's only calling a function. And oftentimes I'll have like 4 or 5 of these connecting events. And so it's just easier to read. I'll show you what I mean in a second, but let's connect it. So to connect this to this player enter trigger, we type player enter trigger, which is going to pull up the this.player enter trigger, so the local method for player enter trigger. And so VS Code is really good at auto-completing and finishing typing things for you, which means you can type less. It's really nice. And then we need to pass in the player parameter. So we do parentheses, player, and then I like semicolon, so I add a semicolon here. And now this line of code is nearly done. And we'll come back to this error code in a second, but if we had multiple, like maybe triggers exited by player or some player enter world and exit world events, Control C, Control V, Control V, Control V, you can see that these events can be easily read. The thing that it's being connected to can be easily read. And over here, what is being done can be easily read because we're only calling functions, right? Like I mentioned, you could technically put a lot of code in there, but please don't. Use a local method or a function call instead. So that way, you know, it's easier to read and you can do singular lines like this. And you can also collapse in VS Code this here, which makes it so you have more space to see. And yeah, so anyway, that is why I keep these on on singular lines rather than trying to split it. And last but not least, Shift-Alt-F, we need to fix this.props.trigger. Because it's undefined, it's not guaranteed to be an entity. What that means is we need to type if parentheses props.trigger, which says if this is defined, then we can do this line of code. Now, I personally use curly braces here and Alt arrow up, so that way this is very clearly a part of this if. And yeah, so now this is connected to the player enter trigger. Okay, I know we're going probably like what feels like 1,000,000 times faster than where we were going just a minute ago. There's no rest for the wicked. We better keep going. I'm like, I know this is fast. These are the basics. So we got to really solidify this because everything you do is related to when something happens, right? So when the trigger is entered, and that has to be connected to a method. Now we've covered those pretty solidly in the beginning, so I'm hoping that solid foundation is making this a lot easier. But do remember, you can always jump to this beginning point again, come back and revisit it as needed. So without further ado, let's jump in here one more time for our final line of code. That's right, there's only one line of code left. Now that we've connected the event, we can just cause the player to go upwards. So we say player dot, and we want to do something to their velocity. And when I hit dot, you get a drop-down list for everything we can do with players. And, oh, we can change their gravity. That's fun. Let's see, jump speed, locomotion speed. I think locomotion speed is close. I was thinking velocity or something, but I think velocity is something we can get, not set. Let's see, velocity dot set. Oh, there is a setter. Sure, we'll try it. And so we're going to set the player's velocity to be an upward bounce. And I think that should be okay. Yeah, okay, we'll try it. And so to create a bounce, you can see it takes a vector 3. And you'll remember that a vector 3 is a class. And to initialize a class, we type new. So we say new vec3, parentheses, and so just like before, we provide the three values, x, y, and z. So we don't need any x momentum. We want y momentum, which is up or down momentum. So we're going to say up of 20, and then z of 0. So there's no forward, back, etc. Control save, and that should send our player flying okay, decently high. I'm not entirely sure. We're going to find out. We can play with this value in a minute, but let's go ahead and press clear, press play. Oh, right. There's two buttons for play, world simulation and this play button. Now, I personally have my world simulation button set so that it doesn't start automatically when I preview the world or when I exit the world. This is so that I have full control over like jumping in, the world running, scripts running, and all that stuff. So I'm going to have to hit world simulation on, then hit play. And now when I walk up to the bounce pad, whoa, oh, that's pretty good. That's pretty good. That's pretty good. Yeah, that's a pretty big jump. You could definitely do a little bit lower, but yeah, that did it. So the question in my mind was, what if I just am walking forward? Yeah, it seemed to be okay. Let's lower this down, but to lower it down, we're going to do a little bit more coding. Also, that was fun. Oh my gosh. And that's what I mean. Action, reaction, creates an amazing reaction in the person. And so like, that was fantastic. That was so fantastic. Back in the code, we have this parameter or like this value of 20. We can make that a property. And so if we do, what I like to do is just do Control C, Control V, and then we can call this, we're just going to call this velocity, or bounce velocity would make sense, right? Bounce velocity. You know what I want to do? I'm going to, there are so many ways to do this. Let's do it both ways. I'm going to go a little bit quick, and then I'm going to slow back down. So bounce velocity will be a vector, and then we can do a default here based off of this one. So a default value allows you to set the value. You can't set a value for an entity, but for something like a vector or a number, you can create one. And so here we've created one. I think 20 was way too high. 10 probably is a lot better as a default bounce. And then right here, we can say props dot bounce velocity. And what's so nice is there's a default value. So there's no worry about it being undefined, because even if we didn't fill out the default would be 0, 0, 0. So it was good all along. Okay, so we've set this up to have a property for velocity. We've set that here. And now we hit clear, world simulation on. Oh, it's still compiling. Looks like it just finished. Hit play, walk forward, boing, boing. Nice. And so that worked pretty well. And now if we exit, the world's still running. We can hit bounce pad, and we can change this to be 15. And we'll go ahead and turn off the world, turn it back on, play, which just really runs the code over again. We jump, much bigger jump, nice. Very good. So a little bit closer to that fun jump we had before. And then the next thing we need to look at is, what if we wanted to move forward? Like, what if we set this to 5? And this is what I was getting at, which I was like, we're going to go fast, because I think this would be really cool. Watch. If we walk forward, whoa, oh, that sent me in the wrong direction. Turns out X is this way. And so it leads to this question of, what if we could fire based on the upward direction of our bounce pad? See the green value? So RGB is red, green, blue, and red, green, blue correlates to X, Y, Z. So this is the X value, this is the Y value, this is the Z value. The world also has X, Y, Z values. These just happen to be currently aligned with the world's X, Y, Z values, but they don't have to be. So let's try something here, where instead of doing bounce velocity, we do bounce velocity, it's literally the same, velocity multiplier, okay. And bounce velocity multiplier is going to be of type number. The default is going to be 10, just like before. And now, the problem is this isn't a vector, right? This is a number, but this takes a vector. If we get the upward direction of self, so we say this refers to self, remember this refers to the whole class or self, we can then say this dot entity to refer to the entity that this is running on, and then we can say dot up to get the upward direction of the entity, and then we say dot get, and then we say dot multiply, component multiply, by props dot bounce velocity. And why is that unhappy? Numbers not, oh, sorry, not component multiply. We just want mul. There we go. And that's going to multiply every component of up against this bounce velocity multiplier. Now, by default, this looks pretty much the same as before. So if we run over here, wait for this to compile, shouldn't take but a sec. And there we go. Clear. Turn world on, hit play, and we walk in, we still bounce up. Very nice. But now what happens if we take this bounce pad, let's duplicate it, Control D, slide it over, and then we can grab our rotate tool here. So we got a slide tool, a rotate tool, grabbing this axis, we'll rotate it like that, and then we'll slide it out like that, and hit play. Oh, I have to start the world simulation on, and play. There we go. And so now we've got one that goes up and one that goes back. And you can imagine that could be the start of a really fun game right there. So, you know, trying to get past the bumps or whatever, or using that to your advantage to get to certain places, and however. And then, of course, you have a property to adjust the intensity, right? So on the bounce pad, you can change each one of these to be different. So this one could be 15. This one could be, if I select the bounce pad itself, this one could be 5, so it's less intense. And then we'll jump into preview mode, and whee, versus, we just barely get knocked off. Just barely. It's like, I can jump over you. Ah, I did it. So, yeah, there you go. That's some basics on creating some player motion, action, reaction, and then also some math stuff too. I'm going to share all of these scripts when we're done, so you'll be able to copy these and download them from the Google Drive. So we'll get to that in just a minute. Whew. Okay. Next up, let's go. Let's think about this some more. This is great, but you know what it's missing? Sound effects, visual effect. It's really missing something. There was something I wanted to show you that I thought would be kind of fun. Let's Control D this one. Oops, Control Z. I meant to duplicate the whole bounce pad, but I messed it up. There's no going back, is there? Well, that one's gone. Careful what you do. Control D. There we go. So, got this one. We're just going to zero it out on rotation, 0, 0, 0, and move it back down to 0.05, and 0, and 4. There we go. Now that we got that back, we're going to duplicate it, and this one was set accidentally to 5. We'll set that back to 10. And then this one is going to be 10 as well. But here's what we're going to do. We're going to create one more property. And I'm going to hit Control C, Control V to duplicate this one. This is going to be called isPlayer is using player forward. And this would be like, what if the player got like a momentum boost? And so this is going to be of type Boolean. The default is going to be false. And so you could have like a special bounce pad with a special color. So let's hit Control Save and then jump back over here. Let's change the color of this bounce pad to be not blue, but red. So you know it's something special, or maybe green because it's kind of like speeding you up. And then down here we'll check the on the bounce pad itself, we'll check the is using player forward, and then going over to our bounce pad, what we could do is say, instead of velocity.set using entities up, we could use the players forward. And we do need to go at kind of like a diagonal to get them to move. If you try to slide them across the ground, they won't move because of friction. So we do need some up. And so I'm thinking, just from a mathematical side of things, we need to create the direction. So let's start by creating a direction. So we're going to say constant direction equals, and we're going to do this dot entity dot up dot get, just like before. But there's a cool thing called a lerp, which I will have to get from somewhere else. So let's put parentheses around this, and we're going to call vec3.lerp. And so vec3.lerp allows us to put in two vectors, and then it goes somewhere between them. And so you can see that you have vector A, vector B, and the amount, which is a percentage between 0 and 1. So 0.5 would find the midpoint between two vectors. And so these are both direction vectors. You have the upwards, which is just 0, 1, 0 in this case because it's pointing up, but it could be pointing backwards. And then you have the players forward, which is player dot forward dot get, and then the amount is going to be 0.5. We could also use player dot torso dot forward dot get, but I think this is going to be fine. This should be fine. I think it's probably default to the players forward anyway. Yeah, so that's going to get those two things, and then instead of this dot multiplied, we're going to use direction dot multiply, and that should give us something pretty solid. I'm a little worried about the direction not being a one vector, a normalized vector. So we're going to say direction needs to be normalized first. So we're going to wrap this in parentheses and then say dot normalize. And what normalize does is it takes this vector and it changes the length to be 1. This is a lot easier to visualize in three-dimensional space. So I'm going to very quickly pull out a shape. A pyramid should work. Pull it out. All right. Oh, that's kind of a pyramid. There we go. Shrink. Control Z. Shrink it down. All right. So you can kind of imagine this is a direction vector, and it's pointing in this direction. Let's assume the length of this is 1 meter. And now that's our up value. We'll go ahead and hit Control D to duplicate and then rotate this. This is the player's forward value. Right about there. Okay. And so what we're doing is lerping between the two of these. And that's going to create a value that is, Control D, roughly, you know, on the diagonal. The problem is the length of it needs to be the same for the velocity application to have the same amount of velocity. If it lerps to rotations, that ends up with the distance being somewhere right here, which might be the case actually as you're looking at this. This doesn't have a length of 1 meter. So what normalize does is it normalizes it out to 1 meter. So it extends the direction vector to have a length of 1 meter. Okay. So if you're not familiar with direction vectors, I think I can use my hands to try to explain this. So let's imagine this is the world's origin, 0, 0, 0. And then you have this direction is 0, 1, 0. So this represents the direction of 0 going up by 1 and then 0 on any of the other axes. So this is world's origin. And then this would be like the player's forward, which would be 0, 0, 1. So X is the forward direction. So imagine they're running forward. On the world's forward, that'd be 1. And so direction vectors are centered on 0, 0, 0. So that you could have like -1 would be pointing down, right? So 0, -1, 0 would be a direction vector of down. Anyway, that's basics on direction vectors. Okie doke. So with that, we've got our direction. We've normalized our direction. So just running through that one more time, we say we've got two vectors that we want to lerp. So we've got the first vector up, we got the second vector forward. We get the midpoint between those two vectors. We then normalize it to make sure it's a length of 1 meter for our direction. Then we take that direction and multiply it by the bounce velocity. And that gives us the amount of force that we want to apply to the player in a specific direction. And yeah, we'll go ahead and try that out. That should be pretty cool. So this one is going to allow the player to go up and forward, which is cool. Like you can, very cool game mechanic. I'm sure there are uses for that. So I'll hit play, and we walk over to the green one. Wow, that was insane. And it goes in any direction the player is facing, right? It does appear to be slightly off. Is it? It does appear. If I. Interesting. We might want to use torso forward. Let's try that. Player.torso.forward. So it's the same thing, but you have the player has like a torso, a head, hands, you know, feet, I think. And you can get the forward direction of all those different things. You can also get the upward direction as well. And then from those values, you can get the rest of the directions. There we go. Let's try this out. I think that was more accurate. Let's try it. Seems good. So we jump on it. Bad, not bad. Okay, so then the thought was, what if we have this same direction? So if we take this one and just turn on the is using player forward. I'm going to turn off the world and turn it back on again to play. What should happen is, because I'm running at it forward, right? It's it really feels diagonal there. I'm not sure about that, but I'm on mobile, so it's kind of hard to tell, or web. But oh, and the amount of multiplier is really low for this one. Now, because I'm walking backwards, you would expect it to, and you can't see it because we're on the back side of a plane. A plane only is rendered from one side. Yeah. Anyway, the point is that this is only using the player's forward direction. It's not using their current velocity, and velocity is something we're not getting into today, but you can see there's a lot you can do. It's pretty cool. A lot of very cool things that can be done. Go ahead and turn that off. I'm not gonna lie, I didn't fully love that implementation. Something felt quite off about it. And I'm not sure what, but yeah, quite interesting. I'm wondering how it would feel in VR. It might feel better in VR versus mobile, where you have less control of your torso. That's what I'm thinking, less control of your forward. Okay. So we have talked about all of this, and now we want to talk about like making sound effects and stuff happen. And as much as we've had fun with this bounce pad, I think we should, well, we can keep expanding upon it. I guess we'll keep expanding upon it. I just wanted to see more basic scripts, because I feel like the further we expand this, the harder it is to really understand it. So let's just do something simple again. So the next script we're going to make, let's go build, new shape. This will be a sphere. Pull that out. And since we're going to be moving along, we're going to just move our character along over here. Do the same thing with this ball. Now this is a really large ball. And if you're building, some sort of ball tag game, that seems reasonable. But in this case, I want it to be more like an engaging ball that you just grab. And so we're going to take the scale of that down to 0.2, 0.2, 0.2. Nice. Then we can so desire to hit the select texture button, but let's just change the color, make it a nice blue. Oh, there we go. That didn't seem to work. There we go. And change that to 1. Very nice. Now with that set up, we can make it interactive. So here we've got motion. We'll make that interactive. And something that's interactive can be grabbed, and therefore we can receive an event when it is grabbed. So we're going to create a new script, which will be called the grab ball, which is an entity. And we'll go ahead and click enter. Go ahead and 3 dots, open an external editor. I'm going to make my typical changes. Expected that to open the script up. That was weird. There we go. So we're going to make my typical changes. Deleting here, deleting HZ and dot, hitting control period, pressing enter to import. I like double spacing there. And we are also going to add a pre-start for our connecting of events, which I will then delete void from. So we're back to where I like to start. Now with this, we're going to think about the grab start. So when a player grabs it, so we call that grab start, parentheses, which then has a player parameter, just like before. And it also has a is right-handed parameter. Now we don't need this is right-handed parameter, but it is going to come in whether we want it to or not. So there it is. Now in pre-start, we're going to connect event before. So we do connect code block event, parentheses. This is now from self because this script will run on the ball. So this dot entity will receive the grab event. So this dot entity, code block events dot grab. We have on grab start. And you'll notice that I mirror the names of these code block events with my names. That's not a requirement, but I find it's a lot easier to read and understand. And so I remove the on and just go camel case grab start. And then we're going to do parentheses arrow function just like before. You can see the parameters listed up here. So the first one is right hand, and the second one is the player. And then we're going to arrow function, curly braces, and we're going to call grab start, passing in the player. And I'm not actually going to pass in the is right hand. We don't need it, but if you do need that for something, you can pass that parameter in, just simply comma and then is right hand, or vice versa if you want to go in the same order they do. We're going to just go ahead and delete this. There we go. And now we've received grab start. And so let's do something really simple here. Console.log player.name.get. Just showing you a couple simple things here. And let's just start by seeing that something's happening. All right, so we've got our console. We're going to clear our console, make sure it's all cleared. And start the world, hit play. Oh, we forgot to attach the script. We can attach the script while the world's running, that's okay. Grab ball is attached. Now jump into preview mode and grab the ball. And we can see Vidyuu is printed onto the console. I can let go of it by pressing the X key, press E again to grab, and you can see it's been printed a second time. Right there, there's the number 2. Turn off world simulation. And yeah, that's the start of our little grabbable ball. And there's lots more we can do, right? So we can do Control-C, Control-V. We can do onGrabEnd, onGrabEnd. And you'll notice that onGrabEnd, when you hover over it, just has player, whereas if I hover over onGrabStart, you can see it has is right hand. So we need to remove is right hand from grabEnd, since grabbing ending doesn't have a hand. And then I'm going to copy this. And I don't recommend copying when you're getting started, but once you've been writing for so long, like 2 or 3 months, I feel like at that point you've got the muscle memory that copying and pasting is totally okay at that point. But building up that muscle memory is what I did. I think I spent 4 or 5 months not doing copy and paste intentionally so that I could just be a better, faster typer. So now we have grab end, and on grab end, we will do a return. So this is, I'm going to leave a comment here. Now, I recommend only using comments when you need to, and trying to never have comments if you can. And so I will delete this comment after I write some return script in here. And on grab start, I would like to play some sound effects. So play effects, which includes sound effects, visual effects, and haptics. And yeah, so these are the things that we want to do. We have this pretty much set up. We've got our 2 events at the top. I'm going to collapse this so we can read this better. And let's start with our sound effect and visual effect. That one's pretty easy. So here in the curly braces, we'll click enter. We need a reference to the sound effect and visual effect. So sound effects, colon, and then curly braces, type, colon, is of type prop types dot entity, and then comma at the end, and then Control C, Control V, and we can do visual effect as well. And these will be referenced on the properties panel. And then here in grab start, we can type something simple like props dot sound effect dot as parentheses audio gizmo dot play parentheses. All right, and I want to pause there for a second because we've introduced a few new things that we haven't seen before. Number one, we have the question mark. This question mark means if this is undefined, return undefined and just don't run the rest of the code here. It's amazing. It's fantastic because by returning undefined, nothing needs to happen as this isn't being used inside of a parentheses or something. Like it's not being used inside of a function or as a parameter. It's just a line of code. So basically this effectively means don't run this line of code if sound effects hasn't been filled out on the properties panel. We then are saying this sound effects is an audio gizmo, and we are declaring that. If we are wrong, that's a problem. But we're saying this is an audio gizmo, and audio gizmos have a property called .play, and so it allows us to play the sound effect. Now I'll hit Control C, Control V, and the next one is the VFX, which is a particle gizmo, which also has .play, and we just change this to be VFX. There we go. All right, and then haptic feedback is relatively easy. We do need to know the right hand, so let's add that is right hand in. Is right hand colon boolean, and then comma, and we'll pass that parameter in again. Is right hand comma. There we go. All right, and then we can come down here and say if parentheses is right hand curly brace. Isn't there a better way to do this? I don't think there is. It's really frustrating that there isn't a better way. And then we do player, Shift Alt F to make that pretty, player dot right hand dot play haptics, parentheses. This was set up so poorly, and no one's ever made it better. So unfortunately, this is the way that it's done. The duration here is going to be 350 milliseconds, so it's a third of a second. Then the strength is haptic strength dot medium, so you get a drop-down list for all the different options. And we need haptic sharpness, which is like how, is it coarse, is it sharp? We're going to use sharp. I think soft is probably better. It's just like a pickup. And then semicolon. And then we hit Control C, Control V, and Alt arrow down. And this is why this code is so bad, because like, what? But yeah, so this is how you have to set it up. But I mean, it's not like the end of the world. There are better ways to write this. I've written some utility scripts that make this better. Like for me, I can just pass in the is right hand boolean, the haptic strengths and stuff, and then it's a lot easier to use. But for today, we're just going to keep it really grungy, raunchy, I don't know, whatever you want to call this. And I now can delete these comments here. There was one other thing that we hadn't seen before, which was this drop-down list. I mean, I guess we've seen it up here, but we didn't talk too heavily about it. This one is genuinely a bag of stuff, just like we've seen a million times. This one, however, is not a bag of stuff. That's why the color is different. And it's the same thing as this one here. No, it's not. These are classes. This one is an enum. And an enum is something that I kind of like. Not everyone likes them. I don't use them very often anymore. I'm trying to get away from them. But there's some niceties to it, right? Like it gives you a drop-down list for these items, and medium is technically stored as the number 2. Never use the number 2. I've seen it used in some code, but don't do that. But haptic strength, medium, allows us to like very clearly, define, make readable code, right? Like this is very readable, haptic strength dot medium. It's very, and then the same thing with soft. So it gives you a drop-down list for all the options available under haptic strength. And then because it's an enum, they're actually just stored as numbers behind the scenes. But you don't have to see that. Anyway, it's great. So, yeah. Okay, I think that covers all the new stuff in this section. Now that we've set that up, we should actually make it work. So we'll go ahead and hit Control Save. We're going to head back over here, press Clear, and we need to attach these sound effects and visual effects. Under Build, there are sounds, and if we search for something good, let's find something. What's going to make sense? Bell, big splash, bird crow. And remember, you can also use that. Ooh, book pickup. That sounds perfect. There's no way to play it from here, so you have to unfortunately pull it out. I do hope they fix that in the future. I didn't expect it to sound so sharp. Let's see if we can fix that by changing the pitch to be -5. The volume to be 0.2. That sounds like turning a page. But it could be like a snatching sound, right? Like -10, play. Change the pitch or the volume to be 0.1. Change the pitch to be -7. So it's like you're snatching it almost. You can change the distance to be like 25 meters, so it's heard from a decent distance. All that seems good. Okay. So well then I like to move this stuff to 0, 0, 0. So there we go. And then we can grab this object, and on the script we have a reference for sound effects, which we were going to use the book. So I can search book and then grab book pickup. Obviously giving these better names and for a real proper world and game would be ideal. Now there is a couple problems that I need to address. I'm going to remind myself. There we go. And hopefully that does the trick. I'm just like, how do I remind myself? There's a trick that I use a lot in my life, which is where you put objects in weird places so that when you see it again, it triggers the memory. Anyway, so that's what I'm doing with my pen. Okay. So we've got this set up. We now need a visual effect. So let's go grab build. So the original visual effects were from this particle effects gizmo, but there's a bunch of new ones that are only available from the assets, which is, oh right, they moved the asset library down here. How interesting. Go to particles, VFX, there it is. And here in VFX, we've got quite a bit. Fire impact, go here rings. There's some interesting looking stuff. You're gonna want to play with these to find what's gonna work best for you. Confetti's kind of cool. I'm kind of thinking I might not want any of these. Ooh, sparkles. Okay, I know, but seriously, let's see it. Let's see them. I don't see anything happening. I think you have to turn the world simulation on to see them the first time. No? Is it because I need to select one from the drop-down list? Hey, there it is. All right, let's change the scale of that. Does that actually affect anything? 0.5, 0.5, 0.5. Play. I don't know. Did that change it? Play it one more time. Go to 0.1. Go and play. That doesn't seem to affect the scale. So let's go to the properties. And here we have lifetime, size, amount, color intensity, travel distance. Here's travel distance. Let's change that down to 0.5. Hit play. That seemed better, but it didn't, no. Was it actually not better at all? 0.5. It wasn't even happy with that number. Ah, there we go, that's better. All right, so here we got sparkle size. Let's change that to 0.5. And 0.1. Hit play. Nice, that's better. Now we're talking. That's really cool. This is so cool. Sparkle's lifetime, 0.2 to 0.7. It's much faster. We've got the glow scale, which we're going to change to 0.5. Right, 0.5, because apparently that doesn't work. There we go. I think that's better. Global scale. Oh, there was a global scale. Well then, aberrations glow scale will change to 0.2 and 0.5 as well. All right, and play. There we go. Oh, I see. There's a bit of randomness in it. Well, I like it. I think it's cool. Let's change the length to be a little bit longer now that it's smaller and not as overwhelming. Nice, that's sick. Okay, try that 1.2 and play. Love it, love it, love it. Okay, that is so cool. This has got to be one of my new favorites. Oh my gosh, it's so cool. So we're going to go ahead and call this sparkles, and we're going to move it to 0, 0, 0, which you'll see has some problems momentarily. And then we're going to start the world. Oh, we need to reference it on the properties panel of this. Go and reference sparkles. Go ahead and get into preview mode. We're going to walk over. And if I come over here, you can really see that's working. The problem is it's not moving to the location. And so that's what we want to do next. And so now we're going to go back into here, and when the grab start happens, we need to move these particle effects. And to do that, we're going to type props.soundeffects.position.set to the this.entityPosition position.get. And semicolon, and Control-C, Control-V, arrow, well, we'll do them in order. And then VFX. Now the problem is, you might have remembered me saying earlier that every time you call this .get, it's not super efficient. So it is better, probably not by much, but it is better to do constant fx position equals, and then grab this right here, Control X, Control V, and then we can put fx position where that was. And that allows us to use that variable twice rather than calling .get twice. So just slightly more optimized there. All right, so now wait for that to compile. We go to the console, you can see it's compiling. Click clear, click simulation on, hit play, walking over, pressing E. And that's interesting, isn't it? It doesn't follow the ball. I feel like it really should follow the ball. I think in that case we need to group them together. It depends on what you want to do, right? Maybe this is maybe getting a little bit out of hand, I think. But let's just quickly go into, we did this earlier. So remember async? So we did async dot set interval, parentheses, parentheses, arrow function, curly braces, comma. We'll set the interval to be 20 times per second, so 50 milliseconds. And then we'll use enter here to create the lines of code. And what we're going to do is move these objects 20 times per second, which starts to be when with this getting the position makes a lot more sense. And then we want this effects to follow it only for like 1 second. So then we say this.async.clear. We want to set a timeout to clear the interval. So we set timeout, parentheses, parentheses, arrow function, curly braces, comma after 1,000 milliseconds or 1 second. We then want to clear the interval. So we say async dot clear interval, parentheses. Now we need to get the ID, which you'll remember we got earlier by saying constant async ID equals the set interval. And then we just pass that async ID in. And now that's going to have those visual effects following it for a second. And the reason I'm doing it this way rather than grouping them together like we did with the trigger earlier is so that we'd only have to have one visual effect and one sound effect for this. There could be 5 balls, and maybe the balls aren't always grabbed at the same time. If they're grabbed at the same time, you usually want to pool your visual effects and sound effects. That is so out of scope for today. But pooling is where you have an array of sound effects and an array of visual effects, and you're pulling from it so that there's always 3 that are active, but maybe there's 10 different objects. So if you have 3 players grabbing the ball at the same time, then all 3 can play simultaneously, whereas with this instance, only 1 could play. That's more a problem when you're like talking about a swimming pool and everybody's jumping into the swimming pool at the same time. If you've only got one visual effect, you get a problem with, it just teleports around a lot. Whereas with a pool of effects, you get like 5 effects going off at the same time. It feels a lot more like a swimming pool. All right, here we go. Ooh, I didn't even see it. That was weird. It's definitely not an effect that can follow. So some effects can follow. I don't know that this one can. It seems to go off wherever it starts. So that just might be a limitation for this specific effect. Just to see, let's try grouping them together. I'm going to Control D this one, slide this over, going to grab the position. We're going to turn off the grabbability of this, so it's no longer going to be interactive. And we're going to remove the script because we're about to group it. So script goes on the top level, remove script. And then we're going to grab the position of this, copy position, right-click, copy, selecting sparkles, right-click, paste, selecting book pickup, right-click, paste. And let's change the scale of that down as well so it's not impeding the view. And then we can select all 3 of these, right-click, create parent, and then we'll name this sparkle ball. All right. And now that we got our sparkle ball, we can now attach the script grab ball. We can then reference these sparkles as the visual effect, sound effect as the sound effect, and last but not least, I think that's it. Oh, we need to make it interactive. Animated, change it to interactive. All right. So we hit world simulation on, play, walking over to here, press E. Yeah, okay, so this one just doesn't move. That is a limitation of that one, and it's okay. Sometimes there are limitations, so there's a few different ways to approach that. And the way that I would approach it would be to take all of this and move it into our set timeout. We no longer need this clear timeout. And I would also move the play effects into here. And we can delete this async ID stuff. And then change this delay to be like 100 milliseconds. So ideally, it doesn't play until it's in your hand, is the idea. So we'll go world simulation on, play, grab it. And that's a little bit better. It's not perfect, but it's slightly better. And there's little things that you can do that are kind of hacky, and most users won't notice. You don't have to beat yourself up about it. So like there's a lot of solutions. Like not having any delay at all is a solution. So, and then you might have noticed that on the sparkles, they were set to play on start. So I'm going to turn that off. And same with, oh no, book pickup wasn't. Yeah, but since this has been changed, we currently have them grouped together. Okay, let's move these out of the group. And I think this is going to cause another little minor issue. So we'll delete this one and we'll focus on the one on the right. If I'm not mistaken, the issue is going to be that, let's see, drop it, grab it. Yeah, for whatever reason, they don't seem to move in the same frame. So right here, unfortunately, what you have to do is duplicate this code again, Control-C, and then paste over the playing. Needs to happen slightly delayed from the motion. Shift-Alt-F to prettify. And so we can delete this moving, because the moving's happening up here. So there's two nested async set timeouts. And so this one is going to play them after a, like, we'll say 50 millisecond delay, which should just be one, maybe 20. Like, it's such a small amount. Like, it's really such a small amount. That should be fine. But basically, this makes sure that they have moved before it tries to play them. Just, you know, sometimes that's what you got to do. A little bit of this and a little bit of that to get it to work. All right. That still doesn't seem to be working. Is it too fast? Like, does this need to go to 200 milliseconds? Does this need to go to 100 milliseconds? Control save. Move, then play. All that seems right. And at the end of this, I'm going to change it to be how I would actually do it, which will be a lot simpler. But I just got to make sure it's working because I don't want to give you bad code. There we go. So it just needed a slightly larger delay. Very cool, very cool. Okay, so now that you've seen that code working, what I would honestly actually do would look like this. Just take this code here, move that up, and delete this delay. I get that it's going to play where they picked it up at. I think that's okay. Clear. Simulation on, play. Like, it's kind of like, I don't know. That's what I would do. It's just, it's so much simpler from the coding side. You just don't have the two asyncs. Either or is a viable option though. Okay. Whew. We have rolled and rolled and rolled. We have just hit the 4-hour mark. Oh my goodness. I'm planning for 1 more hour. So if you're hoping for more, and if you're not, I don't know what to tell you. You saw the time code. So we did visual effect. We did sound effect. We did haptics. That was the wrong to-do list. Re-add those checkboxes. Oh my gosh. Put them on the other side. Yes, so we did the visual effects. We did the haptics. We've done quite a bit. There was one thing I really wanted to do. What was it? It was, I thought it was really important. Oh, teleport. I wanted to write that one down. Teleport. I'm trying to think if there's anything else that's really important that you could do. Because there is so much, but really I just want to get you some foundational knowledge. And I think we've done that, so that's good. So let's talk about teleport and see if there's anything else that pops up along the way. Yeah, all right. Ooh. The most common teleport, oh, right, data. That's what I wanted to talk about. Data files and function files. We haven't talked about that yet. Data and function files. Let's do a little bit of that. We talked a little bit about this idea of having a pool, and let's do that for our spawn point gizmo. Let's create a pool of spawn point gizmos, and you enter a trigger, and it chooses one at random to go to. Oh yeah, I got a little bit of rice left. I'm gonna eat some. I'll be right back. Whew, okay. Yeah, this is definitely my last hour. If we get to 5 hours and there's still more I want to do, we got to cut. I'm like, whew. I'm ready to go lay down. Oh man, but this is so good, and I'm like, I really hope this is helping unlock you. If there is more that you need, just for reference, we have resources on Discord. We've got a link in the description for our Discord. There's channels to ask for help there. And the comment section is a great place to ask. I don't like to respond to comments a ton because it's hard to keep up with, and YouTube doesn't send me all the emails. It's really annoying. So I don't always get those comments anyway. So Discord is the place to go. But yeah, so anyway, I really hope this has been helpful. I think this is really good. I think I've done an okay job. But if there's any areas I can expand on, I would love to know about that too. Obviously, I've made a lot of tutorials and I'd love to keep making more. So here we go. Without further ado, let's get some teleporting happening. So we've finished on this side of things. Let's go ahead and stop the world. We're going to move this guy to the other side. All right. So this next one is the idea that you walk in and you want to teleport somewhere else in the world. We've got our bounce pad from earlier, and I'm just going to Control-D duplicate that, slide it over, and we're going to use this bounce pad as our teleport trigger to indicate that it's a different thing. We'll name it and call this the random teleporter. And then we'll go down to our random teleporter and change the plane color to be red, because I feel like red indicates something dangerous, and getting randomly teleports kind of dangerous. So with that, we will need a different script attached. So let's go ahead and remove that script. And if we go to our scripts drop down for our bounce pad entity, we can duplicate that script to use it as a base. And I do this quite a bit, especially when there's a lot of overlap with scripts. So now let's rename this. And this is now going to be called the random teleporter. It's an entity, and there we go. All right, we'll go 3 dots, open an external editor. Hey, it worked that time. So here we have our script. It has the same name here, so we need to rename this. If you right-click on this class name, you can use rename symbol to change all of them to be the same name. And I want to match my file name, so random teleporter. There we go. And that changed it here, here, and here. So you can see as I double click, it highlights all the places that was at. Now the only thing we need from here is the trigger. That's all we need is the trigger. And we wanted to connect the code block event to player enter trigger, so we've got that. And this is where we want to respawn player to random spawn gizmo. There we go. We're going to come back to that. That's the end of this script for now. Something that I like to do to clean up my scripts, this is just the OCD part of me, is when you see a grayed out one, it means it's not being used, so I just backspace that. Yeah. So now that we've got this set up, we'll come back to write this line of code. It's 1 or 2 lines of code, won't be crazy. But it allowed us to keep our pre-start, our event connections, just delete a couple things. I mean, really nice. Look how fast we got that set up. That was nice. Although I guess I will say, you know, when you're starting out, if you do write this over and over again, it'll make it a lot easier for you later on. So if you do want to create a new script and then just do it again, muscle memory. There's nothing wrong with that. All right, so random teleporter, we're going to attach the random teleporter script. Now the problem is we need more spawn points. So we have this one. We could duplicate it. That's a totally same option, but I want to show you where they come from. So you go to gizmos, and under gizmos, there's a lot of gizmos in here. Like, we're not getting into too many of these. We've got so many. People have been asking for asset pool. They want to talk about world shop. I'll make tutorials on those eventually. I'm not there yet, but we'll get there. Probably in the next 2 months or so. I know that's a long time, guys. I'm sorry. I'm a busy guy. I do as much as I can. But the days, they fly away just like this video has. Let's go ahead and pull out a spawn point gizmo. And this spawn point is going to need to have spawn on start turned off. If you have more than one set to spawn on start, it will randomly select one for the player to spawn in on, which could be a desired outcome. So that's an option. For now, we're just going to have this singular spawn point, and we need this spawn point to register itself to a data file. So we're going to need a couple scripts. And I'm also going to rename this as random spawn point to very clearly differentiate it from the world spawn point, which I will now rename world spawn point. There we go. Now we have our random spawn point, and if we go to scripts, we're going to create a new random spawn point script, which is also attached to an entity, so underscore entity. And this is where we're going to start deviating a little bit, because now we need a script to store this data. So we need random spawn point underscore data. There we go. And there's that done. We'll go open that in an external editor. Now this data file, we don't need anything that comes by default, so we backspace and delete, and then control save. Now we're going to go to our random spawn point entity and do our classic setup stuff. So delete this, delete this, delete that, control period, enter to import. And now that we got this set up, we know that this is attached to a random spawn point. So our random spawn point data needs to have some data stored here that we can add to. So we're going to say export constant, and I like to mirror the file name. So random spawn point underscore data, and then equals curly braces. So we just made a bag of stuff, which allows us to put things in here. And the first thing we're going to put in here, and because it's a variable, it's a constant, you have to declare it above the export. And the constant is going to be called spawn points. Spawn points, simple as that. And spawn points will be an array. So we say, but it's an array of spawn point gizmo. So I'll have to import that. And then square brackets to define that's an array, and then say that's equal to an array to create the array. We can then export that by simply typing spawn points, comma, and now that's added to our bag of stuff. I like to create some space between each of these different sections and control save. Now, when I teleport, I prefer to teleport to not the same one that I teleported to last time, right? Like I want to teleport to a different one than the present one. So there's a, like I don't want to teleport two players to the same one in a row to make it feel more random. Even though that is random, it would feel more random if we didn't do that. So if we track the last used index, that could be useful. I'm thinking. And now I've got it. Okay, so what we want to do is create another variable, which will be a let, and this will be last spawn point index, which is going to be equal to 0. And so we can then say, we can export last spawn index, and now we've got two things in our bag of stuff. All right, so now that we got those things set up, we've got our entity script here to add to this spawn point data. And you remember, we have pre-start available to us, which allows us to do things before the world has started. So we're going to use pre-start to go into the spawn point data, which we'll have to arrow down and click enter, and then dot spawn points, and then dot push, parentheses, this dot entity dot as a spawn point gizmo. So as long as we attach this script to spawn point gizmos, we won't run into any trouble. All right, so we got this set up, and that's all we need to do for this random spawn point. So now we're going to go back into Horizon. We're going to go to the spawn point and attach the script random spawn point entity. There it is. Horizon's got this weird thing where it'll show you scripts that are not attachable until, like when you create them from up here, until you leave and come back. So you'll see some in there that are not actually attachable. Okay. So now that that has been attached, we now have a list of data, which is just one spawn point. And I realize the way that I've set this up, we're going to need at least 3. So we'll start with 3. That's easy enough. So you'll have 0, 1, and 2 filled out. And the next thing we need to do is create some code. And this is where you might have like a function that everyone can use. So you might have more than just this one script that randomly teleports players to these spawn points. So we're going to create another file, which will be called random spawn point underscore function, which is going to store a function to teleport randomly to one of those spawn points. And so random spawn point function, 3 dots, open an external editor, backspace. Same thing as before, export constant, and this is going to mirror as well. So random spawn points data, but then backspace and replace that with func, and then equals curly braces. Now differently is functions can actually be written after the export, which is how I prefer to do it. So that's what we're going to do. And so this function is going to be called function randomly teleport player. Parentheses, it's going to take a player parameter, and then curly braces. So this is the function name and the parameter. Got our spacing all like I like it. And then to randomly we'll export it too while we're thinking about it. Yeah, let's do everything else, and then we'll come write this function. Oops, randomly teleport. There we go. Control save. And then we'll go back to our teleporter entity and just fill this out real quick. So now we're going to call the random spawn point function. Pressing enter adds an import line for you. And then dot randomly teleport player and pass in the player. And now we've finished this script as well. So the only thing left to do is to write this function that needs to pick a spawn point without picking the previously used spawn point. So it'll never use spawn point at index 0 on the first go, but that's okay, because that should be pretty random which one gets to be 0. So it should still be, it doesn't matter. It's the second person it's random for, it's fine. I mean, okay, you're making me do it. -1, we'll do it. -1 it is. So it starts as -1, so that 0 is an option. Okay, so we've got the last spawn index, we got the spawn points, and we need to determine the spawn points. So what we're going to do is say constant available spawn points equals square brackets dot dot dot, and then you go to the random spawn point data dot spawn points. Now there's a new thing here to look at. So available spawn points is an array of spawn point gizmo. This 3 dot operator is called the spread operator. And what it does is it spreads out the items in an array. And by putting it inside of new square brackets, we've effectively created a brand new array. Now this is where things get a little complicated. So just to quickly share what an array is, in case it hasn't been made clear enough, it's like a bag that holds a bunch of items in it. And so you've got this bag, and anytime you reference that bag, you're referencing a very specific bag. So we've just gone and said we picked up another bag, we looked in there, and we said we're gonna use the same items. We made copies of all those items, and we put it in our bag. Okay, so we got a new bag with all the same items in it, but they're 2 separate bags, even though they have the exact same stuff in it, but they're 2 separate bags. Okay, hopefully that makes sense. So now that we've got these, this new array of spawn points, we can now remove the last used spawn point. So we say if random spawn point data dot last spawn point index is greater than -1. So I'm actually going to use greater than or equal to 0. So this means it's a valid spawn point index. Then we can say available spawn points. We need to remove an item from the array. And this is where I use that array function to remove items from the array. So that, but I guess we'll manually type it out, even though I haven't typed it out in a very long time. I've been using that tool for that array utilities file for a long time. Okay, so we need to know the index in that array. Now this index should be the index, so we might actually be good to just do this. We say available spawn points dot splice. Let's read what splice does. Removes elements from an array. Perfect. inserts new elements in place. We're not doing that. Returning deleted elements. With this 0 base location of the array where the start moving elements, the number of elements to remove. Okay, yeah, we're actually good. This is super simple. Because we have the index, we can just say start at spawn point data or random spawn point data dot last spawn point index, and then we just remove one item. So actually, way easier than I thought. So now we have an array, after this if statement, we now have an array that only has items in it that are valid to be used. And now we need to select the spawn point. So we say constant spawn point, which I think it's easier, it's better to clarify that it is a random spawn point. Okay, so our random spawn point equals, and now there's a little bit of math involved, and I'm just going to do it on one line because it's not that hard. But this is also where I would normally use a utility file for this, and I would just call get random item from array, and it would return a random item. But in this case, we're just going to do available spawn points, square brackets. And so available spawn points is an array. When you do square brackets, and let's type in 0, this is going to get item at index 0 from the array. So we need to provide a number that is a random number, whole number, that represents an item inside this array. And so what we do is we say math.floor, because you remember that gives us a full value, like an integer, a whole number, math.floor, and then we need to take math.random to get a random number, which we then multiply by the available spawn points dot length, and that's going to give us a random whole number between 0 and the length of the spawn points, not inclusive of the length, because we're using math.floor, and you remember how it doesn't include that top level value. So if the length is 10, the indexes are actually 0 through 9. And so 9 is actually representing the 10th element in the list, because index at 0 is counted as the first element in the list. So that's how we count in programming. So confusing, but it works. So we have math.random times available spawn points.length to get the index. We have to remove the decimal place. That gives us the random spawn point because we're pulling it from the array. And we can then go to that random spawn point and say random spawn point dot teleport player parentheses player. And that is going to teleport the player to that random spawn point. Okay, that was a lot, but I feel like it wasn't too hard to follow. I think that was okay. Like, it was a lot. Might need to read over it a couple of times, but I think we're good. I want to just look through, see if there's anything really weird that we didn't talk too heavily about, but all of this is stuff we've talked about so far. We've built a very solid foundation, so I think that helps. All right, clear. Everything's been set up, so theoretically, we just hit world simulation on. Did we reference the trigger on the random teleporter? We did. And jump in. Here we go. Hey, and it works. And it chose this one to the right. We'll go again. And it chose this one in the middle. And again, and it chose this one on the left. And the middle. Sweet. So it's definitely, then we're on the right. It's bouncing back and forth right now, but that's only because random numbers are hardly ever random. There it goes. Two middle. Wait. Is that two middles in a row? That's not supposed to be possible. There we go. There. Whoa, wait. Is something wrong in my code? Oh, there is. There's a problem in the code. I was like, that's not supposed to be possible. We forgot to tell it what the last index was. So what we need to do is say, now that we've removed the last spawn index, we can set the last spawn index. And so we say, I think for legibility, it would be better if we did constant random index equals, and then we do this math outside of this, Control X, random index can go right there, math goes there, and then after we're done, after we're done teleporting the player, we can then at the very end say random spawn point data dot last spawn point index equals the random index. So that way it's actually being saved and then removed. Let's give that another try. Clear, world simulation on, play. All right, so we went left. Okay, what? Oh, it just it hadn't finished compiling the code. Start, stop, play. Okay, here we go again. All right, so it went right and center, left. That's 2 lefts in a row. What the heck? We might need to console log some stuff to figure out what's going on here. That's 2 rights in a row. What is happening? What is happening here? Oh, because the index isn't the correct index. Oh, problem. Okay, so up here, we're using the last spawn point index. Let's call this last spawn point, not using the index, because we won't have the index. Yeah, we won't have the index because we've pulled from the wrong thing. Oh, you know what? No, we can. We can do this. Yes, we can do this because, sorry. So, okay. I'm just going to slow down. So if you didn't catch what just happened there, we had the indexes 0, 1, and 2, and then we were removing whichever one was the last one. But we only have 3 spawn points, and we're always removing 1, which means we only have indexes 0 and 1. And so we were always removing 0 or 1 from the main index. Because anyway, we weren't removing the right one, because 1 could have been 2. But yeah. So the numbers weren't right. So to fix this, what we're going to do is, instead of using random index, I mean, like, it might actually cause more problems, like that problem there. So I think it's better to put it right here, since the index isn't correlated to both arrays. And then what we can do is say this random spawn point is how we find the random index, because we can say random spawn point data dot spawn points dot get index, spawn points dot index of, parentheses, and then pass in the random spawn point, and then this index of returns -1 if it's not present, and we already handled -1 cases, so even in some weird oddity case that should never happen, we'd still be okay. All right, clear. Now I'm pretty sure we got it. All right. Let's rerun that code. Off, clear, and on, play. Here we go. All right, so we're on the left. We're on the right. We're in the center. We're on the left. We're on the center. Right. This is looking good. Center. Right. Yeah, this is looking great. Left. Ah, it's so fantastic. Right. Perfect. Perfect. We haven't got center in a few times. Hey, there's center. Fantastic. That is what I'm talking about. So, I think we might have done it. We might be ending half an hour earlier than I was expecting. We've talked about teleporting. We've talked about data and function files. We've talked about a lot of different types of actions and reactions that you can cause and do. And this was really just to get you started. There's obviously so much more that you can do, but I think with this foundation, you're going to be a lot more equipped to handle a lot of the other tutorials that we've already made, and probably a lot of the tutorials coming in the future. So good luck, have fun. There is so much. Programming gives you endless possibilities. So I think there's just this one key thing that I'm trying to figure out how I teach. I don't know how to teach it. I know how it happened to me, and I mentioned it earlier, and I'm going to mention it again because I think it's a great wrapping point, and it's something we should all be striving for those of us who are like, I'm going to be a programmer. It's like equipping your brain. When I was in school, I remember there were some math classes that were actually really hard in like my 4th year of college. I was like, oh my gosh, I cannot wrap my brain around these concepts. And fortunately, Horizon helped me wrap my brain around those concepts, thankfully. But the point is that it wasn't really the math. It was like you were rewiring your brain a little bit. with these math concepts and trying to like think in these kind of almost fourth dimensions. And when I started programming, I didn't really, there was just following tutorials for a very long time. It wasn't until I came to Horizon I started building things and seeing things happen that I was able to connect, like, okay, the player grabbed the thing, then they pulled their index trigger, which then launches a projectile. When that projectile hits another player, then that's going to send some message to a data file, which is going to subtract a point from that player, and then that's going to play some visual effects at the same time. And like, if that number is ever, less than 0, that player's dead, at which point we respawn them. And so it's just these layers of thoughts of like connecting if statements and functions, and like how does it all work together, and how does that chain of reactions and actions come together. And obviously you can imagine that would be a really long thing. So if you can split it into smaller files, like we saw today with the function file, where you no longer had to have all of that code inside of that one script, you could put it into a separate script so that you didn't have to think about it. So when we think about this, what I just described there, where it's like, okay, so players, pulled index trigger, launches projectile, maybe that's on a gun, right? That makes sense. But then the projectile hits the player, and there's some sort of hit manager function. And the hit manager function has to play a visual effect and a sound effect. And there's a whole function for playing visual effects and sound effects. So that way the hit manager can also think about like what happens if the health goes below 0. And if it does, it sends a message to some sort of like death manager, which then says, oh, I've got a death event. What do I do? How do I respond to the player? And so on and so forth. So I hope sharing that kind of context can help bridge your brain into becoming a programmer brain. But I'm like, I don't know what the answer is. That's what I'm trying to solve this summer, is how do I equip you all and everyone who's trying to become a programmer to be able to do this effectively without needing to ask for help. And like I see a lot of people, when I was teaching, I taught pretty much all last year. I was a mentor with Meta. And the biggest problem was every student was asking, how do I do something? They never were able to figure out how to do it on their own. And I don't think I ever did a good job teaching how to do it on their own. That's what I'm trying to do this summer. I want to learn how to teach you to do it on your own without even needing me to ask me a question of how is it done. It's not about what the thing is that's getting done. It's more of like equipping your brain to solve that problem. That's what I want to do. So we'll see how far I can get. Let me know if you have any suggestions. If you got ideas and things that work for you, feel free to drop them in the comments. I would love to hear them. You can hit me up on Discord. I'm LakeSo5 there. Vidyuu Discord is linked in the description, and feel free to reach out. All right, guys, I will catch you in the next one. Without further ado, bye-bye.